All right, welcome to Your Friend Alyssa Teaches You Git. We're going to start with some quick introductions. So first of all, who am I? My name is Alyssa Hursh. I am a C6 alum of Ada Developers Academy. Ada Developers Academy is a coding bootcamp for women and gender expansive adults based out of Seattle. I was a student at Ada in 2016, and I have been a full-time software engineer in the industry for 5 years. I love teaching Git. I've been teaching Git to beginners in one-on-one settings for the last 2 or 3 years, and I've learned a lot from that experience about how to teach Git effectively. I wanted more people to be able to benefit from that, and so I created this course. So what is this exactly? This is my opinionated guide to learning Git. So there are lots of ways that you could learn Git, lots of tutorials, books, etc. This is my opinionated guide. This is how I like to teach it. I found that this process works really well, and this is actually how I use Git every single day. So we're going to go through my Git workflows. This course is designed for beginners with 2 to 3 months of experience using Git in an educational environment. So I'm expecting that you have added a file in Git, you've committed a file in Git, you've pushed something to origin, you've pulled something from origin. You've been doing this for a little while, but you're still feeling like you're kind of tripping over yourself and want to deepen your understanding of Git so that you can use Git more effectively. My goal here is to make using Git feel like breathing air. So Git is one of those things that we are going to use every single day. No matter what language or what tech stack you're working in, you're very likely going to use Git as your source control. So investing really heavily in Git is going to pay dividends for you across the entire length of your career. Git is a tool that can help us work much more effectively, much more efficiently, but that's only going to be true if we're really comfortable with it. So I want to get you to the point where using Git feels like breathing air. You do it without thinking. So how to use this course? There are a lot of ways that you could go about this. Here are a couple suggestions that I have. One, you can make a cup of tea, settle in, and watch the whole thing in one go. I do actually really recommend that. I know it's very long, but I think that seeing that full overview and understanding everything that Git can do for you is going to help you develop your own work process. And then when you run into problems, you'll know how to where to come back to find that solution. So make a cup of tea, settle in, put on your jammies, get your pet, sit on the couch, and just hang out with me for a while. Another option here is to watch a few chapters at once and then come back when you're ready. So I've divided our sections into 35 or so separate individual chapters. Pick the first 5 or 10, work on those, and then take a break. Come back next week. Another way you could do this is to just watch a single chapter with a buddy and then stop to practice the skill in that chapter. You can practice these skills in any repository. So if you have a repository that's just yours, that you can do anything that you want to it and you're not worried about impacting anyone else, pull up that repository and try some of these things alongside me. If you work with a buddy, that person can help kind of check your understanding. So watch a chapter, stop and practice, watch another chapter, stop and practice. Or lastly, you can just watch the one chapter that you need extra help with. So if you're in the middle of something and you've gotten yourself into a Git pickle, you can come to the chapter about that particular concept to kind of reconfirm your understanding and get yourself out of that situation. So feel free to engage with this in any way that's going to make sense for you. Okay, I'm going to have a little caveat here about disagreements. So anytime that you teach a technical topic, someone is going to disagree with you. That is fine. As my own mentor says, there's more than one way to pet a cat. So in Git, there are a ton of ways for us to accomplish the exact same outcome. I'm going to teach you the ways that I accomplish my work. If you have other ways of accomplishing work, or there's a strategy that you like better, or if your own mentor is teaching you something different and has good reason for that, that's totally fine. There's more than one way to pet a cat. We don't all have to use Git in the exact same way. That said, I love learning. So if you know something that I don't, teach me. Go ahead and send me an email, put a comment on the video, explain the thing that you know, and teach that to me. I am a student too. I'm going to be a student for the rest of my life if I'm lucky, and I love learning. So if you've got a different way of doing something, tell me about it. All right, with that, we are going to hop right into it. All right, before we get into Git, I want to spend a little bit of time here at the command line, just getting a little bit more comfortable and efficient using our terminal. So I've worked with beginners for a pretty long time, and there are a couple of things that I see people do over and over and over. I want to teach you how to not do those things. So one of the first things that I see is that folks will copy and paste something into the command line, and then maybe they'll change their mind and realize they actually don't want to run that command. So I'm going to paste a big chunk of text here. I just copied this off of the internet. It's just some random generated text. And let's say that we're here at the command line, we pasted something in here, and now we actually don't want to run this command. Normally what I see people do is try to just backspace their way out of it, one character at a time. And that can work if we have a really short command, but it's going to take us a very, very long time if we have even a medium-sized command. So I want to show you what you can do instead, which is that there's actually a command that just deletes it. It's Control-C, that's it. Anytime that we've got something happening at our terminal and we just don't want it anymore, it's just Control-C. So there it is. We did it. Control-C. One more time, I'll paste all of that in, and then Control-C, and I've got a totally fresh command line. So I want to make sure that we're not using that backspace key over and over when we don't need to. Control-C to get a fresh command line. The next thing that I see a lot is that I know that you know how to do an up arrow and a down arrow to get back into some previous commands. Here are some previous commands that I've run recently. Sometimes I'll see beginners use that up arrow to try to get to a command that they ran a week ago, a month ago. They're like, I know it's up here somewhere. I'm going to find it eventually, okay? I want to show you a better way to find those commands. So I'm going to, same thing, hit that Control-C just to get this command out of my command line. Start fresh, and then we're going to do a Control-R. Control-R is going to open up our back search, and this is going to allow us to actually start searching through previous commands that we have run. I've run a ton of Git commands while working on this Git tutorial, so if I type Git here, back search is going to find the last time that I actually ran a Git command. So there it is, git add app. If I do a Control-R again, we're going to start searching through commands that start with Git. So now, instead of up arrowing through everything unrelated or related to Git, now we're just searching through the stuff that starts with Git. If I know that I had a command that started with even more than Git, so I know it was Git and then it was commit, I'm pretty sure. Okay, now as I Control-R, I'm going to be searching for commands that start with git com, as you can see. Same thing, if I type more of it, maybe I'm only looking for the times that I did git commit -m, Control-R, and now I'm only looking at those commands, okay? So rather than up arrow up into oblivion, we're going to use that Control-R to search for commands that start with a particular set of characters. Again, I'm not actually going to run this command. I'm not in a directory that has Git, and so to get out of it, Control-C, right? Okay, there we go, all gone. Another thing that I see sometimes is that folks will have maybe a fairly long command that they have put into their command line, and they're down at the very end of the command, and then they want to change something at the very beginning of the command. And so I'll see folks do this back arrow. I'm just clicking that left-hand arrow to slowly go back to the very beginning of my command. There's a faster way to do that, and that is Control-A. Control-A for the very beginning of the alphabet is going to take us all the way to the very beginning of our command line. Control E for the word end is going to take us to the very end. So Control A one more time, and then Control E to go to the beginning and the end of the command, rather than clicking here one character at a time. Same thing, I'm going to Control C to get rid of this command here because I don't actually want to run it. We're back at a fresh command line. The next thing that I want to show you is the difference between running the command clear and running the command Command K. So I can type the word clear. You might be familiar with this. If I hit clear and then I enter, it's going to move everything up to the top of my screen. But I still have the ability to roll back if I want to, okay? So typing the word clear basically just moves my command line all the way up, but my history is still here. Oftentimes, when I'm running a command, I actually don't want to be able to scroll back to see stuff. And so that's when I'm going to use that Command K. So I'm going to scroll here so we have everything on the screen. And now I'm going to type a Command K to completely clear my screen. So Command K. Now I actually have no scroll back. I find this really helpful if I'm running a command and I know there's going to be a lot of output and I don't want the output of this command to maybe get confused with the output of previous commands. So Command K to completely both clear the screen and get rid of all of my scroll back. Those are the things that I use the most frequently at the command line. There are a ton of others. I would really encourage you anytime that you find yourself doing something that feels wrong. So again, in that case of trying to click back one character at a time, or trying to delete one character at a time. Those are both going to be signs to you that, hey, there's got to be a better way to do this, and it's worth taking that pause to invest in learning how to do that efficiently so that you don't have to keep wasting that same time over and over and over every single time, deleting individual characters or moving one character at a time. Okay, so Control C to start back over, Command K to clear. That is my little introduction to working at the command line. All right, now we're going to do a quick intro to Vim. So Vim is a super basic text editor that we can use inside our terminal. A lot of times folks think that Vim is scary, and that prevents them from actually learning how to use the tool. I don't use Vim all the time, right? I'm normally using a true text editor or an IDE, but having some Vim comfortability is really important, especially as we get into Git, because we're going to use Vim a ton while we're learning Git. So the first thing that we're going to do here is just create a file that we can work with. I'm going to touch a file called tutorial, and then we're going to open that file in Vim. So Vim tutorial is going to open that file. I'm expecting this file to be empty because we just created it. You watched me do it. I'm going to hit the letter I to enter insert mode. So that's like the most important lesson we have in Vim, is that in order to type, we have to be in insert mode. Here it is, down at the bottom it says we're in insert mode. If I hit escape right now, I'm going to get out of insert mode, okay? So I to enter insert mode. And now we're going to type a couple of things just so that we have something to work with. So this is the first line. I can't type. This is the second line. This is the third line. Okay, so we have a little bit of text now in our file. I'm going to go ahead and hit the escape key to exit insert mode. You can see at the bottom here, I'm no longer in insert mode. There are a couple of things for getting around in Vim. So one is just using our up and down arrows. That's pretty easy. Same thing with our left and right arrows. That's a fine way for us to get around. There are a couple things that can make us a little bit faster here. So if we wanted to get to the very beginning of the line in Vim, that's going to be the 0 character. So just clicking that 0 takes us to the very beginning of the line. If we want to get to the very end of that line, it's going to be the $sign, okay? So $sign character takes us to the end, 0 takes us to the beginning, up and down arrows to change lines. There are a couple of commands that we're going to use over and over and over as we're doing Vim in Git. One of them is the command to delete a line. So in Vim, if we're not in insert mode, I can delete a line by clicking the D character twice. DD to delete the line. There it is. 2 Ds, line is gone. that line is actually now in our paste buffer. So we're able to paste that line again if we want to. I'm going to paste that line at the very bottom of the file. So I'm going to hit the down arrow. And then in Vim, it's going to be the letter P to paste. Pasting this line is going to put the line after the line that I'm currently on. So there it goes. We can see now that our first line has been moved to the bottom. And we've got second and third right above it. So one more time, that was DD to delete the line. And I'm going to paste it actually in between the second and third. So P to paste. There it is, second, first, third. So we're just reordering these lines. If I wanted to put that first line back at the very top, I'm going to DD to delete that line. I'm going to hit I to enter insert mode and add a blank line, and then escape to get out of insert mode, and I'm going to paste. And then there it is. We've got that first line up on top. If you know more about Vim than I do, you might know better ways to do that, but these are the ways that work for me. There's one more command that I want us to be comfortable with, and that's DW to delete a word. So when we're doing stuff in Git, we're going to use this a lot, DW to delete a word. I'll do that right now, just DW. There it goes. It's gone. Again, that single word is still in my paste buffer. And if I want to paste it back in the right spot, I'm going to hit I to enter insert mode. And then I'm going to give myself a space there. I'm going to escape out of insert mode and then P to paste. That worked okay. I'd enter insert mode and then I'm going to delete that. So as you can see, I'm not a Vim expert, but I'm comfortable enough getting around, and I want you to have about that same level of comfortability. The last thing we need to do here is get out of this file. Getting out of Vim is the #1 highest ranked question on Stack Overflow. It's not hard, but if you don't know how to do it, it's impossible. So we're going to hit escape to exit insert mode. Okay, and then it's going to be a colon down here that allows us to actually start typing our commands. And then we're going to type the letter W to write and the letter Q to quit. In my head, I always say that as escape colon write quit. I'll say it out loud a bunch. You're going to hear that, my voice saying that in your dreams one day. Escape colon write quit. We're going to hit enter, and that's going to save the file. We can see those changes by opening the file in Vim one more time. I'm going to delete this extra line. And then escape colon write quit to save the change. If we want to just see the file inside our terminal, we can do that two pretty easy ways. One of them is cat. Cat is just going to print the file to the screen. Cat does a lot more, but one thing it can do is just print the file to the screen. There it is, so we can see our 3 lines. And then the other one is the less command. Same thing, less can do a lot more, but in this case, it's just going to show us the actual file. So less tutorial, and then to get out of this, it's just gonna be the letter Q. Okay, so a couple different ways that we can see those files inside our terminal without actually opening up a separate text editor. That's the basics of Vim that I want you to have going into the rest of these tutorials. To learn about a new command line interface, one of the best things that we can do is ask that tool about itself. In Git, that's git help. When we run that command, we get this file, which is divided into 3 sections. The first section is usage. It tells us how we actually type our Git commands. The second section is a list of the most common Git commands. And the third section down here is instruction on how to get more help. If we look at the top of the file at the usage commands, we're going to see this pattern a lot, so it helps to be able to read it. What this is telling us here is the name of our command, that's git. It's giving us a list of options that we can run on the git command. Most of these options I don't actually have any experience with. I've used -- version, and obviously right now we're doing -- help. So we're going to skip straight down to the part we actually use all the time, and that's going to be this git command and the command arguments. I want to talk a little bit about this syntax here. We see the word command inside these triangle brackets. Anytime we see triangle brackets, that is a sign to us that we need to replace that word with a real thing. In this case, a real command, and we're going to replace the triangle brackets too. So triangle brackets are not coming with us when we type our commands in Git. What this is telling us here is that we are going to run git, some subcommand, and then some optional arguments. The list of common Git commands is right below, and it gives us some commands that are grouped together by kind of different situations. So we have some commands for starting a working area. We have commands to work on the current change. We have commands to examine the history, to grow, mark, and tweak common history, and to collaborate. This is not nearly all of the Git commands, it's just the most common ones. When we get down to the bottom of the file here, we have some instruction on how to get more help. So here it says we can run git help A or git help G to get a list of available subcommands. That's going to be that -A flag, or a list of concept guides. That's going to be the -G flag. It also says that we can run git help and then the name of a subcommand to get more help about a particular subcommand. So we're going to run all three of those things just to get a flavor for what's inside each of those commands. When we run git help -A, we get the whole list of Git commands. It's very long. I would say that I know maybe 10% of these, and I have to read the documentation for everything else. Git divides its commands into the porcelain commands and what it calls the plumbing commands. The idea here is if you think about like a porcelain sink, the sink itself, that piece of porcelain, is the piece that you actually interact with on a daily basis. The plumbing is stuff that we only use or we only interact with when something has gone wrong. So everything down here, the ancillary commands, everything below the porcelain commands, Git refers to as the plumbing commands. We're mostly going to be focused on the porcelain commands. To get out of this documentation, we're going to hit the letter Q on the keyboard, and then I'm going to do a Command K to reset my screen, and we will run git help -G. Git help -G opens the concept guides. Git has a bunch of different concept guides that talk about different specific concepts in Git. One of the concept guides that I really like is this everyday guide, which is a useful minimum set of commands for everyday Git. So this is the stuff that we're actually going to be using all the time. The other concept guide that I reference a lot is the Git glossary. Git has a lot of very specific terminology that is mostly only used in Git. So having a glossary where we can read the definitions of some Git specific words is really, really helpful in understanding the rest of the documentation. Those are the concept guides. The last thing that we see down here is this git help command or git help concept. So if we want to open a concept guide, we'd run git help and then the name of the guide. First though, we're going to run git help on a specific command. I'm going to run git help on the commit command so that we can read the git commit manual. And I picked this command because you probably have some familiarity with it. You probably run git commit or git commit -M and feel comfortable using that command. I always like to read documentation about stuff that I feel comfortable with because it helps me understand how to read documentation. So at the top here, it gives us the name, git commit, and it tells us that this is going to record changes to the repository. Then it gives us that usage guide again, this little synopsis that says, here's how we actually run this command. We're going to use the words git, commit, and then a whole host of optional flags. So we have all of these 1- or 2- flags that we can use. And we're going to get down further into the documentation to be able to see what these things actually are. The next part of this particular file is going to be a description, so it explains in more detail what git commit actually does. So if we want to understand what's happening under the hood, this is a great thing for us to read. I'm going to skip a little bit further down into this documentation, and we're going to look at the flag that I think that you have probably used before. That's going to be the -M flag. So oftentimes we run git commit -M, and then in quotes we put the commit message that we actually want. This is the description of what happens when we run git commit -M. So one thing that I want to point out here is that we actually have two options for how to do this. We have the -M flag and we have the -- message flag. So in most circumstances, when we see, and this is true of most command line tools, when we see a single dash and a single letter, it's almost always short for something longer. So in this case, dash M is short for dash dash message. One way that I try to remember this, the short flag and the long flag, is that when something is going to be long, it's really long. It uses 2 dashes. And when something is short, it's usually just 1 letter and then only 1 dash. So when it's long, it's really long, and when it's short, it's really short. We can read the description here about what actually happens when we run git commit -m. It says, use the given message. We can see that that's the actual argument that's being passed into that optional flag. Use the given message as the commit message. If multiple -m options are given, their values are concatenated as separate paragraphs. So this is something I actually didn't know until I read this documentation. You can pass in -m multiple times and it'll separate it into paragraphs for you. So rather than trying to, at the command line, create multiple paragraphs, we can let Git do that by just putting a -m in front of each paragraph we want to include. Reading the documentation is really helpful. So that's the -m command, or option rather, sorry. Obviously with git commit, we have a lot of other commands that we could run. Here's another one that you might have run that I run all the time. This is git commit -amend. We're not going to get into detail about what this means, but we could sit here and read about exactly what happens when we run that -amend command. So we'll close out of the git commit manual, again with that letter Q. Again, I'm going to command K to just clear my page. And then we can look on the other side, we can look at one of the concept guides. So the one that I liked was glossary. Here's the Git glossary. It describes in detail all of the words that you need to understand in order to be able to read this documentation. So if you're looking at something and you're just like, man, that doesn't mean anything to me at all, we can hop in here and we can actually read, what does commit mean? We've got a description as a noun and a description as a verb. So this is super, super helpful for being able to read the Git documentation. That's just a high-level overview on looking at the Git manual. And I would spend some time just getting a little bit more familiar with that because it's a very, very helpful tool. We're going to start by just getting a lay of the land. I've set up a couple small things so that we have something to work with as we get to know Git. So I've got a little package here that I'm calling gitignore. Over on the right-hand side in the terminal, I'm in the root of that package. Over on the left-hand side, I have IntelliJ open with the package itself. You don't have to have any familiarity with IntelliJ specifically to be able to understand what we're going to do in Git. So if you don't have IntelliJ experience, don't worry about that. I'm going to show you a couple things in IntelliJ though. We've got over on the left-hand side here this project tree that shows you the layout of the actual files in our project. So we have a directory called gitignore, that's actually the package itself. Inside there we have a directory called app, and then one called source, and then we have 2 packages, one called main and one called test. Inside that main package, we've got our actual Java code, and then inside the test package, we have the unit tests for that code. You'll also see that we have some files related to Gradle. Gradle is the build system that I'm using for this package. You don't have to have any understanding of Gradle to understand the stuff that we're going to do in Git, so don't worry about that either. This layout that you see here is specific to Gradle, so that's why we have these packages laid out in this particular way. In the actual package, I only have 2 real Java files. I've got a little file called calculator and one called calculator test. I'm going to close the tree here so that we can see these files a little bit better. So we've got this calculator file. It's just a class that's called calculator. It has one public static method that's called add. Add takes 2 integers and it returns those 2 integers added together. Over on the test side, our test suite here is using JUnit 4. We have 1 test so far. It just tests that add method, and it asserts that we get the result 2 from adding 1 and 1. In IntelliJ, I can run my tests here. I'm going to show you that because we will do that a number of times, and that's going to just assert that those tests all passed. So that's the left-hand side of this. We've got IntelliJ set up. Over on the right-hand side, we've got our terminal. I've already initialized Git for this package, and I've done a little bit of work in this package already. Anytime that we start working, we want to start by running a Git status. So before we do anything else, we always want to know what state we are in. So I'm going to run Git status here, and we're going to talk about this output. Reading this output is really helpful. Sometimes our eyes can glaze over a little bit when something looks a little confusing or overwhelming. And that's how I used to feel about this type of output, but actually we can read this together. So first thing that it says is that we are on branch main. Main is the branch that we're gonna be working on all the time. And I'll talk about that a little bit more about some Git strategies that I have, but we're always gonna be on main. Our local main is ahead of origin main by 4 commits. So I have 4 commits here locally that I haven't yet pushed up to origin. In my case, I'm using GitHub as origin. I've got these 4 commits and I just haven't pushed them to GitHub yet. Git is telling us that we could git push to publish these local commits. So if I wanted these commits to be in origin, I could git push them. I'm not going to do that right now. And then the last thing that it tells us is that we have nothing to commit and our working tree is clean. So we have 4 commits locally that we haven't pushed to origin, but we don't have any other changes. We don't have anything that we're in the middle of. Working tree is clean. This is the kind of state that we want to be in all the time, always returning to that clean working tree. If we run git log, we're going to get some output here to see the actual commit history. So we've got 5 commits total. All the way down at the very, very bottom, we have our initial commit. This is the only commit that I've actually pushed up to GitHub at this point. And we can see that here in parentheses, it says origin main or origin head. So this commit is the commit that is the tip of origin main out in origin, in this case in GitHub. Everything else that's sitting on top of that commit, so these 4 commits here, are only local to me. They are local on my local main, and we can see that here. It says we've got main as our branch. These 4 commits are all on main locally here. The commits that I've got here are just a couple of things that I did to get the project actually set up. I want to show us one more way that we can look at our git log. So if I command K to clear my screen and then I run git log one line, I really like the one line output here. It's just a little bit more abbreviated. We still have all 5 of our commits, but instead of taking up the whole screen, we just see the commit messages themselves. We can see that we have that initial commit, the one that I've pushed up to GitHub, and then we've got these 4 commits that are sitting on top of that on my local main. So that's basically the lay of the land here. We've got a small package, a little calculator class, a small amount of Git history, and we're going to build off of that point as we work through our lessons. So starting with this calculator class, we're going to add another pretty simple calculator method. So same thing, we're going to make a public static method that returns an int, and we're going to call it subtract. It's going to take 2 ints. We'll call them A and B for now. And it's going to return A minus B. All right. Because we've added a new method, I want to make sure that we also add the new test to go with it. So we're going to switch over to the test file, and I'm going to type out the new test. So we're using that JUnit annotation for the test. JUnit tests are always going to be a public void, and we're going to test the subtract method. So subtract. And we're going to assert equals that 1 is going to be the same thing as calculator.subtract 2 minus 1. There we go. I'm going to run that test to make sure that my test passes. Great. I'm actually going to run the entire test suite to make sure that I didn't break anything about the original test or the original code. It says that both tests passed. And then I'm going to run my build tool just to make sure that everything runs as expected. So I'm going to run Gradle test on this side and just make sure that everything is still good to go. So that's perfect. We have a small change. We've added a small test. I'm going to run a git status here, and we're going to talk about what we actually see in the output. So we're still on branch main. Our branch is ahead of origin main by 4 commits. It's the same 4 commits as before. And we have some changes here that are not staged for commit. So we have changes to files that Git is already aware of, but the changes themselves aren't actually staged for commit. This area of the Git status output is called the working tree. So when we have files here not staged for commit, we have files in red, that means that we have changes in the working tree, or Git actually would call that a dirty working tree. So we want to commit these changes. So we need to actually stage the changes in the index. So I'm going to run git add, and we can git add everything with a git add dot. We can git add everything that's inside a specific directory with a git add app, for instance, or we could git add the individual files. In this case, I actually want to add both files. They go together. And so I'm just going to do a git add everything. Anytime that I change anything in Git, I want to run git status because I want to see that the thing that I did actually happened. So my expectation here is that these two changes are going to be moved from the working tree in the changes not staged for commit area, and they're going to become part of the index in that staged area where the files turn green. So git status, there we go. We have changes to be committed. Our changes are now green, so we've got changes in the index, and we're going to actually commit those changes. So I'm going to run git commit -m, and I'm going to give this commit a message. There's a particular format that we use in commit messages. So our commit messages are always going to start with a capital letter. They're always going to use the imperative tone, and they're never going to end in punctuation. The imperative tone, or the tense that we're looking for here, would be something like add instead of added, add instead of adding, replace instead of replaced, right? So that imperative tone, it's going to sound like a command. So in this case, we added a subtract method. So the message here is going to say it's going to say add subtract, can't spell, subtract method. There it is. In the imperative, no punctuation, commit messages start with a capital letter. So that is a beautiful commit message. I'm going to hit enter. And then I'm going to run git status one more time. When I do this, I'm expecting that I won't have any files in the staging area, and I'll have 5 commits sitting on top of origin main. So git status, we see that we have 5 commits. We see that we have nothing else to commit. Our working tree is clean. So that is a really simple addition and commit. I want to talk a little bit about commit objects and how we can reference them. So I'm going to start by running a git log so that we can see some of the commits that we have. So here's the commit that we made together. It's that add subtract method. Here are the other commits that I have locally that I haven't yet pushed to mainline. And then here's that commit again, the initial commit that has been pushed to origin. So there are a couple different ways that we can actually talk about or reference commit objects. The first way that we can talk about a commit object is by this big gobbledygook number. That number, that output here, is known as the SHA-1 hash of the commit, or more formally, it's known as the object name of the commit. We'll talk a little bit more about how the SHA-1 hash is generated later, but that is one way that we can reference our commits, is by their SHA-1 hash. So here we've got a SHA-1 hash that starts with 7533. Down here we've got one that starts with 1C52. In general, we don't actually need the entirety of the SHA-1 hash. We only need the first 6 or 7 characters. So sometimes you'll see an abbreviated SHA-1 hash that's only 6 or 7 characters, and that's almost always enough to uniquely identify the exact commit that we're talking about. In addition to the SHA-1 hash, we can actually refer to commits by some specialty reference names. Head here is a specialty reference. Head is always going to be pointing to the tip of the branch that we are on. So if we wanted to refer to this particular commit, we could just refer to it as, in all capital letters, that special keyword head. Down here, we have another commit that has some special keywords attached to it. Here in the parentheses, we've got the identifier origin main or origin head. So this commit we could refer to by its SHA-1 hash, or we can call it origin main or origin head, and Git will understand all of those things. If I run a git log one line, we can see that slightly abbreviated version of Git history. And you'll see here that in the abbreviated version, Git uses that 7-character SHA-1 hash. So we only need those first 7 characters, and that is almost always good enough to reference a commit. We can see that this one again is called head, this one's called origin main or origin head. And we can practice actually using those with the git show command. So git show is going to show us the contents of a particular commit. If we run git show and we don't give it a specific commit, it's always going to show us that git head. So git show, this here is our head commit. So all the way starting from here, we see the SHA-1 hash of that commit. We see that the commit is also called head. We've got our commit message there with that imperative add, and then we have the actual files that were changed. So we can see that we have a calculator file that has some additions and that test file that has some additions. We did that change together. So that's the head commit. It's the most recent one we've got. If I git log one line again, we could actually get the same output by saying git show and then that SHA-1 hash. I will show it to you. So that was git show and the SHA-1 hash. There's the command that I ran. Same thing, same SHA-1 hash, same exact output. So head and that SHA-1 hash are currently equivalent references. If I command K to clear the screen, we'll do a git log one line again. We can run git show on this commit by referencing it using that SHA-1 hash. So git show and then that particular commit. This is a commit that I made before we started working together. The commit here says replace Gradle init boilerplate with add method. So I actually removed some code. I added that add method. I removed an old test and added my own test. So that is the commit right before we started working together. I'm going to Q to get out of this and then command K to clear my screen again. Git log one line. Same thing. If we want to see this one, we can git show that SHA-1 hash. There's the commit that's 2 commits ago. Q to close out of it. Command K to clear the screen. I'll git log one line again. Like I said, we can actually refer to this commit down here by that origin head or origin main keyword. So I'll show you that. This is the SHA-1 hash. Git show that SHA-1 hash. This was just the initial commit that I made where I added a README. I added one line to the README. If I run that same command, git show and then origin head, it's gonna be the same thing, right? So those are 2 different names for that same commit. I have one more way that we can talk about commits, and that's using the head tilde notation. So this particular commit right now is head. If I want to refer to the commit right before it, this commit is actually known as head tilde 1. So that's a referential way that we can refer to commits, is just going back in time tilde and then the number of commits backwards that we're talking about. So head tilde 1, head tilde 2, head tilde 3, head tilde 4, head tilde 5, right? We can use that exact same command, the git show head, and we'll put in head tilde 1. That's going to show us this commit 1C522B4. Again, we can see that here it is, git commit 1C522B4. We've got our commit message and the actual diff. Same thing, Q to close out, command K to clear the screen, git log one line. We looked at this commit a couple of times, our initial commit. So this one is going to be, let's count backwards from the top, 0, 1, 2, 3, 4, 5. So this commit is going to be head tilde 5. If I git show head tilde 5, we're going to see that initial commit, same thing, there's the abbreviated SHA-1 hash, and now we have the full SHA-1 hash, and just the addition, adding one line to the README. So those are different ways that we can actually talk about a particular commit. All right, now we're going to talk about amending a commit. So amending a commit just means that we are going to actually change the commit itself. Normally I amend a commit if I have put something up for code review or for pull request, and I've gotten some comments on that code that someone wants me to make some changes to it. I want to make sure that those changes are incorporated into the same commit and that they aren't just a second commit sitting separately, because I want all of my commits to be really beautiful individual units of work. So we're going to run a git status here just again to see where we are. We're on branch main. We're ahead of origin main by 5 commits. I'm going to run that git log one line again. So recently together we added a commit that adds the subtract method. I noticed while I was doing this that I can't type, and I made a mistake. I actually mistyped the word subtract. That's a pretty big error in the name of the method, so we really need to fix that. I'm going to just git show that particular commit. So it's head, so we'll talk about it as head, git show head. We can see that I named the method subtract, and I call that in the test as well, subtract, right? So we got to fix this thing. Before we fix it, I want us to keep our eye on this SHA-1 hash. So again, we only need to remember the first little bit of it. If we just remember the number 753, that's going to be enough. So put 753 in your head. I'm going to actually clear my screen here, and we're going to jump back over to IntelliJ. So I made a little mistake. It's not great. I'm going to change that to be the method subtract. I'm going to change this to call the method subtract. I'm going to rerun my tests because I've made a change and I need to make sure that my tests still run. So I'm going to rerun this particular test. Ooh, give it a second. There it goes. So we'll give that just a second to run in IntelliJ to make sure that our code still builds and our tests still pass. There we go. Same thing, I'm also going to ask Gradle to just prove it to me that all of my tests still pass. We'll give that just a minute on this side. Everything compiled, my tests pass, that looks good to go. I'm going to give myself a git status here so I can see my change. So again, I have 2 changes in the working tree right now. These changes are not staged for commit. I can call git diff to see the actual changes. There they are. Just removing that extra S so that I spell subtract correctly. There it is. Command K to clear the screen. And I'm going to give myself a git status again. You'll see that I run git status all the time. I really recommend that you do it too. It just helps understand exactly where we are. So we've got these 2 commits, or these 2 changes. I want to stage them, and then we're going to amend the commit. So git add everything, git status to make sure that those changes are actually in the index. There they are in green, changes to be committed. And now we're going to call git commit -- amend. Again, I had talked a little bit about that SHA-1 hash, and I'm going to pull it up one more time just so that we can remember, because I already forgot the number. We have that SHA-1 hash right now. It's 753328B. When we amend the commit, we are changing the commit. We're actually making a brand new commit. And so we're going to get a brand new SHA-1 hash. So I'm going to run git commit -- amend. You can see that my command line wants to help fill in this extra flag, this no edit flag. I'm not going to run that one quite yet. When we run git commit -- amend, it's going to open up the Vim editor for us to modify our commit message if we want to. We actually don't need to change this commit message. It's the correct commit message. So I'm going to hit escape to make sure that I'm not in insert mode, and then :WQ to write and quit out of Vim. And now Command K again to clear my screen. If I git status, we can see that I have 5 commits still only 5 commits. I don't have any changes in the working tree anymore because I actually committed those changes into that last commit. So we're back to the working tree being clean. If I git show, remember git show is always going to default to just showing the head. If I git show, we can see that commit. So here is that head commit. Remember how I said we were going to get a new SHA-1 hash? This is the new SHA-1 hash. So it used to be at 753 number. We've made a change. It's a totally new commit. It gets a totally new SHA-1 hash. So our new commit is E6D, etc., E65D, etc. We can see in the diff that the commit now basically looks as though I got it right the first time. So instead of saying subtract, it says subtract. We've amended that commit, fixed my little mistake, and now we're good to move on to future work. We're going to get into some more advanced adding. So we're going to use the git add flag that's called patch, --patch or -p. The patch flag allows us to interactively add smaller pieces of our diff. So rather than adding the entire file, it lets us add parts of our changes. This is really useful if you were working on something and then maybe you got a little bit distracted and you started working on a second idea simultaneously, and all of a sudden you've realized, oh no, I'm doing 2 things at once, which we can't do, and we need to separate out those 2 ideas into 2 separate commits. So before we get started on that, I'm going to open up the git help, the manual for git add. Anytime that I'm using an option that I'm not familiar with, I just like to read the manual so that I can understand how the thing actually works. So in git add, we have this option here, --patch or -p. If I scroll down, I'm going to get to the actual description of it. So here we see -p and --patch. They're the same thing. This is very common in a command line interface that we have a long version and a short version of our option. The long version is always going to be a full word or maybe multiple words, and it's going to have 2 dashes. The short version is usually going to be 1 letter and 1 dash. The way I remember this is that if it's going to be long, it's very long, 2 dashes. And if it's going to be short, it's very short, 1 dash. Anytime that you're using a command line tool and you're using a single dash, it stands for something, and you can ask the command line tool what it stands for. I find it really helpful to know what those single dash flags stand for. So in this case, -p, --patch, they're the same thing. This is going to allow us to interactively choose hunks of patch between the index and the work tree and add them to the index. And it says this gives the user a chance to review the difference before adding modified context to the index. That might be a little bit hard to understand right now, so we'll do it together and then hopefully it'll make a little bit more sense. I'm going to hit the Q key to exit out of the manual, and I'm going to run a git status because I like to run git status all the time. So you can see that we are still here on branch main. My branch is ahead of origin main by 5 commits. We've seen those 5 commits together a couple times. We have nothing to commit. Our working tree is clean. So we are in a really nice state here. We've got these 5 commits, everything else super tidy. We're going to make some changes, and while we're making those changes, we're going to get a little bit distracted, and we're going to change our opinion about some other stuff. And that's going to force us to use that patch flag. So just in this same little calculator class, I'm going to add another method. We'll add one in here called multiply. And let's see, give me a second to type it. All it's going to do is return A times B. So you give it 2 numbers and it just multiplies those things together. Anytime that we add a new method, we're going to want to make sure that we add the test to go with it. So over here in the test file, we're going to add this, let's see, test method to test multiply. Helps if I spell multiply correctly. And we're going to assert equals that the number 6 is the output. I'll get rid of that tooltip for us. Is the output of 2 times 6. So calculator dot multiply 2 and 3. Sorry, 2 times 3 is 6. That's basic math. So I'm going to run that individual test. Just make sure that it works. Beautiful. We can see that our test passed. This alone should be a commit. We've added something, we've got the test for it, but let's say that we got distracted in this moment. We forgot to commit, we started thinking about something else, we started doing some additional work. So I'm going to go back to our calculator method, and let's just say that actually we're sitting here and gosh, I wish that these variables had better names. So I'm going to call this one first and this one second. I'm not saying that those are actually better variable names. It's just that we're making a change that's unrelated to adding that multiply method. So naming this one first, and then we're going to name B second. And I'm also going to move this onto its own line there. That looks great. I'm going to save that. And I'm going to run my tests just to make sure that all my tests still pass. Great, my tests pass. And then I'm going to run git status. We can see here that we have 2 files that have been modified that are in this area, the working tree area, where the changes are not yet staged for commit. We still have our 5 commits. If I'm going to command K to clear my screen and then git diff to see what the actual changes are. And gosh, this is the moment where I realized I was doing 2 things at once. Can't do 2 things at once. A commit needs to be about a single idea. And so I actually need to split these changes into 2 separate commits. So we're going to have a commit that's just about adding this multiply method, and we're going to have a different commit that's about changing these variable names. I'm going to command K again to clear the screen, and then it's going to be a git add -p or a git add -- patch. Again, those are going to be the same thing. When I go to add something with this -patch flag, we're going to enter an interactive mode. So Git's going to be giving us some options and asking us what it wants us to do. So the first thing that it's showing us here is the first hunk that we have available. Hunk is kind of a funny word, but I like it. It's just like a chunk of the diff, and Git is saying, I think maybe these things all belong together. Git is just doing that based on proximity. These lines are near each other, and so Git's like, I don't know, is this what you want? Does this all belong in one commit? In this case, the answer is no, because we can see on the screen that we have the changes for changing that variable name, and then we have the changes for introducing the actual multiply method. So this is 2 different ideas. We actually want to split these out and add them separately. Down at the bottom here, we have this little array of letters. And then we've got that question mark. If we enter that question mark as our command, Git is going to give us a definition for all those letters, which is super helpful. It's really nice if Git can just tell us what Git can do. So here we have all the different letters. We've got Y for yes, stage the hunk. We've got N for no, do not stage the hunk. We've got Q to quit, A to stage this hunk, and then all the later hunks. D to not stage the hunk, and then not stage any of the later hunks to basically exit out. S to split our current hunk into smaller hunks. E to manually edit the current hunk, or that question mark to print the help. Anytime that we get into the area where we're maybe trying to edit the hunk manually, I would say that's a relatively advanced thing to do. So ideally, you are working on one concept at a time, and we don't actually need to be doing this kind of deep adding work. But in this case, we're just going to split our hunk into smaller pieces, and we're going to let Git do that splitting for us. So we can see the hunk again. It's kind of 2 different ideas, and I'm going to hit that S command to split that hunk into 2 pieces. So now Git is giving me the first half of that hunk. This first half is just about changing the variable names. So we can decide if we want to commit this half first or the other half first. I think I'm actually going to commit the other half, the multiply half first. I'm going to skip this piece. I'm going to say no. And it's going to move on to the next hunk. This is the actual addition of that multiply method. So I'm going to say, yes, I want that hunk. And then we've actually moved on now to the next hunk, which is the change to the test file itself. So this is the addition where we added that test method. And I want that one too, because it belongs with the multiply method. So the multiply method and the multiply test are going to come together. So yes to that. That was all of the hunks that we had to add. So we're now out of our interactive add and we're back to our command line. I'm going to Command K to clear my screen again. And then I'm going to do a get status. This time when I do the get status, I'm in this kind of split state. So I have changes in the index that are ready to be committed, and I also have changes in my working tree. We can see that the file calculator actually shows up twice. Part of those changes are in the index, ready to be staged. Part of those changes are still here in the working tree, not ready to be staged. If I do a get diff is going to show me the stuff that's in the working tree, not show me the stuff that's in the index. So if I do a get diff now, I expect that that's going to show me the place where we change the variable names, because that's the stuff that we haven't actually staged yet. So get diff, all we have there in that file is just the change of the variable names, right? Everything related to adding that multiply method are in the index. So with those changes in the index, I'm going to commit that set of changes. So git commit -m. We're going to call that this add multiply method. And I'm going to hit enter, get status. So now we can see that we actually have 6 commits sitting on top of origin main. And we still have changes here in our working tree that have not actually been committed. Again, if I run get diff, those changes are going to be the variable name changes. And then if I do a get log one line, we can see that we have that new commit, the add multiply method commit. If I get show that commit, we can see that this new commit, it's right here, it starts with db0ad. Here's our commit message, add multiply method, and then here are the actual changes inside that commit. So we have the change to add the multiply method, and we have the change to add the multiply test. One more time, I'm going to get status. So we still have those changes over here hanging out. The variable name changes are still hanging out in the working tree. At this point, if we want those changes, we need to commit them separately. So I'm going to get add everything, because I don't have mixed work now. I only have the changes to the variable name, so I can just add all of it together. Get add everything. Get status to see that I've added those changes to the index, right? The file's now green, changes to be committed. And then get commit -m, and we're going to say change variable names in add method. Again, commits always start with a capital letter. We use the imperative so that it sounds like a command, and no ending punctuation. Beautiful. Get status. Now we've got 7 commits. We have nothing else to commit. Our working tree is clean. If I Command K to clear the screen and then get log one line, we can see that we have 2 separate commits. We've got the add multiply method, and we've got the change variable names in add method. 2 different ideas, 2 different commits. We separated out adding those using that -- patch flag, and then committed them both separately. That is a more complex way to add files and then commit them. All right, now we're going to talk about some restore and reset commands. So sometimes you're working on something and you're not exactly sure where it's going, and you're just starting to make some changes, right? And so let's just say that we are in here and we have started making changes. We've added a comment about something, and let's see, maybe I'm actually going to change this so that it's on 2 lines like that instead. And I'll add another comment in here to do, remember to do something. That's a good to do. And we'll add this one as well. So now I've made a bunch of changes to this file. This is another comment. And let's say that I got to this point and then I'm like, oh, you know what, I'm not sure that this is the direction that I want to go in. This is not what I want. there are a couple ways that we can get back to where we were. One thing that I see people do a lot is that they'll come here in IntelliJ and they will just try to manually delete the things that they did. So they'll say, okay, well, hold on, I'm going to get that to do goes away, and then I think that this was all on one line. And so they'll spend some time really trying to individually undo changes. First of all, in IntelliJ and in whatever IDE you use, there's going to be a native way for us to be able to do that, right built into the tool. So here in IntelliJ, we can see that there's this column on the left-hand side next to our numbers that has some different colors to it. We've got this green showing us that we've added a particular line. And we could click the rollback button and actually delete that if we wanted to. I'm going to undo that to bring it back. We've got this blue showing us that we've changed some stuff. So here's what it used to be. It used to be a single line, and now it's actually 3 different lines. I'm going to add another comment in here. So if we wanted to, we could actually click here and roll that back, all of that just undone back to whatever is happening at origin head. But I'm going to undo that as well and leave the change. Sometimes we just have so many changes that going through and clicking each individual place feels really repetitive. And it's just like, I just want everything to go away. I want it to be like I haven't ever done anything at all. So if we head over to Git and we do a git status, that's not how we do git status. There it is. Git helpfully has the command to run. So here it says git restore the name of the file to discard changes in the working directory. So if I know I just don't want any of those changes, I just want them to go away, I can run git restore and then the name of my file, enter. And when I run git status again, that change is gone. I'm going to give IntelliJ a second to just catch up. Our changes that we made that we didn't actually want, with a git restore, we just got rid of them. So if we have files that are in that working tree, in that red state, running a git restore just discards the actual change. If we had added these changes to our index, so I'm going to add the change to the index, that's going to be our actual change. Git status here. If we add that file and then git status again, so we can see that we've added a comment and we have it here in the index ready to be committed, the restore command actually changes a little bit. So when the file is staged in the index, the option that we have with git restore is to unstage the file, to move it back into the working tree using the staged flag. So here, if I git restore the name of this file with the staged flag, and then we do a git status again, we can see that we used to have the change staged to be committed, and now we have the change back into this area, into the working tree where it says changes not staged for commit. So that can be really helpful if we accidentally added something in that staged area and we just want to unstage it. And then same thing, now that it's unstaged, we can actually get rid of the changes entirely. So git restore and then the name of the file, git status, and those changes are totally gone. If I let IntelliJ catch up, the comment will disappear. So that, I think, is a really great way. If we have some changes and we're just like, oh man, I just don't want these anymore, get rid of everything, we can restore individual files back to the state that they are at that head commit. Now we're going to talk about a couple git reset options. So in order for this to make sense, I'm going to start by making a couple changes in a couple places. First thing always is just a git status. And then I think actually what I want to do here is I'm going to make a new directory called notes. And I'm going to make a file in that notes directory called links to share, because I have some links I want to make sure that I share with you at the end of all of this. So I've made a new file. I'm going to git status just to see that. So we can see that we have notes here in that untracked, the directory notes in this untracked files area. If I run git status -u, I can get the longer version. I think that's helpful just to be able to see exactly what's inside that directory. So we have this links to share file that we've added. I'm also just going to make some more changes in a couple places. So I'm going to add another method in here called divide. Give it a second. And let's see, that's just going to return A over B. Great. So now we've got changes in two different places, get status. We've got that modification to the calculator file, and we have this untracked file here in my notes. Since we're adding that divide method, I am going to go ahead and also add the test method too. There we go. And we're going to change the call here to divide, and then we're going to swap some of these numbers. So let's say 10 divided by 2, and we expect that to be 5. Great. At that point, I'm going to run my tests with Gradle test and just make sure that all of the tests still pass as expected. So there we go. And then we're going to do a get status now. So now we've got some changes that we can actually work with here. I'm going to start by adding all of this. So get add all and then get status. There we go. We've got the modified files, the calculator and the calculator test. And then we have this new file that notes and then links to share.md. Sometimes we just get a little bit heavy-handed with that get add. We add everything and then actually we realize, this is really two ideas. We added the divide method and we added this notes to share file. We don't want those to be added together, but we've staged all of that to be committed. So one way that we can unstage that work is just to run a get reset to head. Get reset head here is going to just unstage those changes. You can see that Git tells us that. It says unstaged changes after the reset. If I get status, we can see we're back to that state where we have the changes not staged for commit, and we have our untracked files separately again. So that's one way that we can reset, just get reset head. I'm going to go ahead and add that notes file and actually commit it. So I'm going to do a get add notes, get status to see that we added it, so that notes and then links to share is up here in the index, and the changes to add that divide method are not. I'm going to commit that as add links to share. And then I'm going to get status one more time. So now we're up to 8 commits locally. If I get log one line, we can see that last commit that I added. And then we can see this divide, the divide work that's still separate here. So if I get status again, I'm going to add all of that divide work, and I'm going to commit that to get commit -m add divide method. All right, and then get status. I'm going to show us another way that we can reset. So the first way that we reset was just to reset our stage changes back to head, to basically get the things out of the index, put them back into our working tree. We can actually get reset to a previous commit. So if I get log one line here, we have all of the commits that we've been working on, and we have this last commit, this head commit. If I want to, I could actually get reset to this point in time. It's going to uncommit the commit. So the commit's going to go away, but the work is still going to be there. So if I get reset, and I can do this referentially by that head -1, so get reset to head -1, which is going to be here, or I can get reset using the SHA-1 hash. I'll do it with the SHA-1 hash. So get reset to that SHA-1 hash. It unstaged those calculator changes again. If I get log one line at this point, you can see that the divide method commit is gone. Here is the head, which is going back in time, excuse me, going back in time to that add links to share commit. The add divide method commit is no longer with us. But if I get status, the work is still here. So we still actually have the changes. If I git diff, you can see those changes. There's that divide method and the divide test. So with that git reset, all I've done is reset to a previous commit, but any of the work that was in there is still there. I'm going to add that again, and then I'm going to commit it again using the same message, and I'll give us that git status. So again, we've got 9 commits. If I git log one line, you can see all of those commits. I'm going to actually reset us further back than that. So if I git reset head tilde 2, so again, this is 0, 1, 2. If I reset to this point, I'm going to get that links to share file back into my working tree, into that uncommitted area. I'm also going to get the divide method stuff there. So git reset head tilde 2, we're going to go back in time 2 commits. All of the changes are still going to exist. They just won't be committed anymore. So git reset head tilde 2, git status. We can see again, we've got the calculator changes here, not staged for commit, and we've got those untracked files again. So we undid the commits, we didn't lose the work. If I git log one line, we can see that head now is pointing to this change variable name commit. The commit where we added the notes and the commit where we added the divide method are now gone. We still have the work, we don't have the commits. I'm going to go ahead and recommit the work again. So git add notes, git commit -m add links to share, git status again. So we've added that commit with the links to share. We're going to add the commit for the divide method, git add everything, git status all the time. We can see that those changes are now staged to be committed, and we can git commit -m add divide method. If I git status now, we've got 9 commits locally. If I git log one line, we can see what they are. So we added these commits, we reset to remove the commits, we added the commits back in. So that is a git reset. This time we're going to look at a hard reset. With a hard reset, we're actually going to lose the work. So we only want to do a hard reset when we've got a commit and we just want it gone. So I'm going to do a git status here again and a git log one line so that we can see we're still on branch main. We're still ahead of origin main by 9 commits. And these are the 9 commits that we have. If I am looking at this work and I just don't want it anymore. I added that little links to share file, but I didn't put anything in it. And I don't need this divide method. I can run a git reset --hard and set myself back in time to any commit that I want. We can only go back in time to what's in origin, right? Anything that's in origin, that is official. We're not going to get rid of that work. But anything that belongs to us that's in our local commit or our local branch, we can get rid of. We can destroy these commits if we want to. So I'm going to actually reset us. We're going to do it twice so that we can see it twice. I'm going to reset us once to this commit. So we're going to get rid of the divide method. Git reset --hard to that commit. And you can see now that it says that head is at this DC7 add links to share commit. So head used to be pointing to this commit up here. That's 7.1 commit. And now head is actually pointing to DC7. If I git status, we still have a clean working tree. We only have 8 commits. So that divide method commit, it's just gone. It doesn't exist anymore. Git reset --hard is going to completely get rid of it. If I come over here and let IntelliJ catch up, you can see the divide method doesn't exist. The method itself should go away. Oh, give it a second. There it is. The divide method has gone away. The divide test has gone away. We don't have those changes in our working tree anymore. Divide is just absolutely gone. If I git log one line again, we can do the same thing. We can reset even further back. So we could reset hard to this commit DC, which is also right now, it's also called head ~1. Again, this is going to be head that's 0. Going down 1 commit, that's going to be head tilde 1. So if I git reset hard to head tilde 1, then this add links to share is going to completely go away. The work is going to be gone. All of it is just gone. So same thing, git reset dash dash hard head tilde 1. It says head is now at this DC commit. Change variable names in the add method. Command K to clear my screen, and then git status again. Now I only have 7 commits. We started with 9. We reset by 1 commit. We only had 8 commits. We reset by 1 commit again. We only have 7 commits. Our working tree is clean. That work is effectively no longer with us. I'm going to show you one more way that we can use that hard flag to reset stuff without actually deleting an entire commit. So sometimes you're in the middle of work and let's say we haven't even committed it yet. So I'm going to come back in here and I'm going to give us that divide method. Helps again if I can spell correctly. Int b, and then it's going to return a over b. So we've got our new divide method. If I git status, we can see that we have that change here, not staged for commit. We've modified the file. If I git diff, we can see the actual modification where we added that divide. I can actually reset hard to head, and that work will just go away. So I don't even have the commit. I just don't want this work anymore. I want it to go away entirely. I can git reset hard just to head. Remember, head is the tip of the branch that I'm working on. And when I do that, that work that I had not staged for commit, that adding the divide method, is just going to be gone. So git reset hard is just gone. I didn't want that work anyway. We could have done a git restore of that file instead. Those two things in this case are going to be equivalent because we only had the one file that had a change in it. I like a git reset dash dash hard head when I have changes kind of all over the place and I realize I just don't want any of them. I was playing around, I modified a bunch of files, I want it all gone. Git reset dash dash hard head is going to get rid of everything that I have that I was kind of working on, but I just don't care about. So those are a couple ways that we can use that git reset dash dash hard flag. We got to be a little bit careful with that hard flag because we are really going to be obliterating that work. It's not necessarily irrevertible. We always have access to the reflog, but we're not going to get into the reflog now. So let's just treat a reset dash dash hard as being pretty difficult to undo. Concept of an interactive rebase. So first thing, like always, we're going to give a git status just to see where we are. I'm still on branch main, and main is ahead of origin main by 7 commits. If I give myself a git log 1 line, I can see that I've got this initial commit that I've pushed out to origin, and then I have the 7 commits locally that are sitting on top of that origin main or origin head commit. So these 7 commits right now are only local to me. I haven't shared them with anyone else, which means that they're mine to do whatever I want with. If I want to delete them, if I want to reorder them and put them into a different order, if I want to amend them or change the wording of the commit message, all of those things are available to me until I actually push them out to origin. An interactive rebase is the way that we are going to work with the commits that we have locally. And I want to point something out before we enter the interactive rebase here. When we look at our commit history with git log 1 line, we start with head at the very top of our list, and then our commits get older as they go down the list. When we open this up in an interactive rebase, that order is going to flip upside down, and that can be a little bit disorienting the first time that you see it. So I just want to point that out now. The change variable names in add method commit, this commit right here, is going to be on the bottom of the list when we open up the interactive rebase. To open up the interactive rebase, we are going to type git rebase -i. The I here is short for interactive. And when we do that, we're going to open up a Vim editor. So this page can look a little bit overwhelming at first if you're not familiar with it. But what we have here is a list of all of our commits, the 7 commits that are local to us that I have not yet pushed to origin. And then below that, we have all of the instructions. So this is just Git helping us understand how we can interact with this interactive rebase. Like I mentioned before, when we look at our commits in this interactive rebase format, our commit history has been turned upside down. So that change variable names in add method commit that is head, it's the top of our branch, in this view is at the bottom of the list. Sometimes it's a little bit confusing. You're just going to have to get used to that in particular. Our commit history here is upside down. What we have here are a bunch of commands that we can use to edit our commit history. So we've got this keyword pick. It means use the commit. Here we can see we have the word pick in front of all 7 of the existing commits. We can replace the word pick with any of these commands to do something different. So one of the simplest ones that we have here is just reword. It means that we're going to use the commit, but we're actually going to stop and edit that commit message. Later, below that, we've got edit. Edit says that we're going to use the commit, but we're actually going to stop for amending that commit. So it's going to give us the option not just to change the commit message, but also to actually change the commit itself. We've got the squash command. Squash means that we're going to use the commit, but we're actually going to squash or meld that into the previous commit. So we're going to take 2 commits and we're going to turn them into a single commit. Fixup is really similar to squash. It means that we're going to take 2 commits, 2 or more commits actually, and squash them down into a single commit. But fixup says that we're going to discard this commit's log message and we're going to use the commit that we're actually squashing into. So I like fixup a lot because it's just a little bit faster and simpler than squash. And then we've got a whole bunch more here that honestly I don't use. I use the first 5 and I've never really looked at the rest of these. So we're going to focus on the first 5 that I know really well, and we're going to probably skip over the ones that we've got down here. I encourage you to read through this and learn more about the additional commands that are available, but we're going to focus on those first 5. Okay, so we were just looking at the Git rebase interactive screen. We're going to do a couple interactive rebase commands together. The first thing I want to do, as always, is just a git status so I can see where I am. So I'm still on main, still ahead of origin main by 7 commits. I'm going to give myself a git log 1 line here so that we can see those commits. And we're going to imagine that we want to change this particular commit message. So we know that if we wanted to change the commit message for head, this change variable names in add method, if we wanted to change that commit message, we could do that just with a git commit -- amend. That would open up the editor to change the commit message for that head commit. I'm going to escape :WQ to quit out of Vim. If I want to change this commit message instead, I'm going to need to go into an interactive rebase because I need to be going back in time. I want us to just kind of keep in mind the SHA-1 hash of this commit and this one as well. So we have 2 SHA-1 hashes that start with the letter D. And we're just going to keep that in the back of our mind as we go through these changes. So we're going to change the commit message for add multiply method. And we're going to do that by entering an interactive rebase. So git rebase -I. We can see from the list of available commands that we have this reword command, use the commit, but edit the commit message. So that's what we want to do. So I'm going to arrow down to the word pick, this line that we have for add multiply method. This is the one we decided that we wanted to change. In Vim, I'm going to type the letters DW. So I'm not in insert mode right now. You can see that down at the very bottom here. It doesn't say insert. So I'm going to type DW, and that's going to delete the word in Vim. Then I'm going to type I to enter insert mode. You can see I'm now in insert mode at the bottom of the screen. That means that I can actually type into the file. We want to use the reword command, so I need to type either the word reword or just the letter R. Those 2 things are going to be equivalent. I don't like typing, so I'm going to type just the letter R and then a space so that we've put the space between our command and that SHA-1 hash. And now we're going to save this file as it is, and that's going to kick off the actual interactive rebase. So escape to exit insert mode. In Vim, you can see I'm no longer in insert mode because I clicked escape, and then :WQ to write and quit. This is going to stop in the Vim editor for that commit message. So I said that I wanted to modify the add multiply method commit message, and I think I'm going to change this to the word introduce because I'm having a hard time. It's a calculator, and every time I see the word add, I'm getting a little bit confused. So I'm going to, in Vim, type DW to delete the word add. I'm going to hit I to enter insert mode. So here again, you can see I'm in insert mode. And then I'm going to change this keyword to be introduce. Introduce multiply method. Somehow that's a little bit easier for me to understand. I've changed my commit message, so I'm going to hit escape to exit insert mode, : and then WQ to write and quit, and hit enter. That was the entirety of that interactive rebase. You can see here that it says that I've successfully rebased. I was in a detached head, but now I'm all done. So I'm going to give myself a git status so that we can see what that looks like. So in git status, we've got 7 commits still. We started with 7, we still have 7. I'm going to command K to clear the screen, and then git log -- one line to see that history. Perfect. So I can see that this commit is now called introduce multiply method. This method, or this commit though, I want to point out, has changed in a couple of ways. So not only did we change the actual git commit message, but we've also now modified the SHA-1 hash and the SHA-1 hash of the child of that commit. So anytime that we change a commit, we're going to change the commit that we're on and actually everything that's after it, because each commit references its own parent, and the parent of this commit, of the head commit, has changed. So we've got 2 brand new SHA-1 hashes for those 2 commits. I'm going to go through that process one more time, and we're going to do the same thing for this commit message because it also has that word add, and I'm feeling confused by that. So git rebase -I, and we're going to arrow down to this commit message, DW in Vim to delete the word, I to enter insert mode, the letter R, and then space, so R again for reword, escape, :WQ. I'm going to hit enter. I'm back in Vim with the commit message for the subtract, DW to delete that word, I to enter insert mode. I'm going to type the word introduce instead. That's going to be my new commit message, escape to exit insert mode, : WQ to write and quit. I'm done with that rebase, and now if I type git status, I'll see that I still have the same 7 commits. Well, not quite the same 7 commits, but I have 7 commits. And if I type git log -- one line, you'll see that I've changed that commit message from add subtract method to introduce subtract method. I've also changed the SHA-1 hash of that commit, and I've changed the SHA-1 hash of all of the children of that commit as well. So you can see this SHA-1 hash has been updated from that number, and the SHA-1 hash for head has been updated from this number. That is using an interactive rebase just to reword an earlier commit. So we've used an interactive rebase to reword earlier commits. There are a lot of other things that we can do with an interactive rebase. So the next one that I'm going to show you is how to reorder 2 commits. So same thing as always, we're going to start with that git status. I'm still on branch main, ahead of origin main by 7 commits. I'm going to git log one line so that I can see those. And I'm going to specifically point out this commit here. So it says change variable names in the add method. This commit happens after I add the multiply method, the subtract method, and I've got this commit here where I actually introduce that add method. I kind of want this commit to be closer to that commit. So here's where the add method gets introduced, and then here's where I change those variable names. I haven't pushed this work to origin yet, so I could actually get these commits a little bit closer to each other, and that might be helpful for someone in the future to have the work in a slightly different order. So in order to do this, I'm going to enter an interactive rebase. and I'm going to take the commit that I want to move, so this change variable names in add method, and I'm actually going to temporarily delete that line. We have to be a little bit careful when we delete lines in an interactive rebase because, as it says down here, if you remove a line, that commit will be lost. It's just gone. So if we delete a line here and then we don't put it back somewhere, we're going to lose this commit. There's also the instruction here that says these lines can be reordered. They're executed from top to bottom. So these commits are going to get applied to our origin head commit from top to bottom. So if I want this commit to come after that commit, I'm going to delete it and I'm going to put it up here. In Vim, to delete the entire line, it's the letter D twice. So I'm going to type D twice. I've deleted that line. I'm going to arrow up to the commit that I want to have right before this commit. In Vim, we can hit the letter P to paste within our paste buffer. So when I hit DD twice, I put that line into my paste buffer, and now I'm going to paste it back by typing the letter P. It's going to paste after the line that I'm currently on. So one more time just for kicks, I'm going to DD to delete the line. I'm going to move up to the line that I want it to come after, and then the letter P to paste that back. So I've taken these commits now and I have reordered them. When we reorder commits, we are liable to put ourselves in a situation where we create a merge conflict. So where we have changes that actually just aren't easy to reorder. In this particular case, I think that these changes are going to be easy to reorder because they don't really interact with each other. We have the addition of that multiply method and the subtract method. The variable naming stuff happened in a different section of that file. And so I don't think we're going to have any problems here where we have some conflicts that are going to make this difficult. So I've reordered those. I'm going to hit escape just to make sure I'm not in insert mode, and then it's :WQ to right quit and enter to get out of Vim. It says that we've successfully rebased, so I'm going to give myself a git log one line to see that. And here you can see that we've taken this commit, the change variable names in add method, and we've moved it further down right on top of the method or the commit that I wanted it on top of. So now I have this commit where I added the add method, and then I have the commit where I changed the variable names in that method, and then I have the subtract and the multiply. So that is reordering commits inside an interactive rebase by deleting a line and then moving it to a different part of the file and saving that interactive rebase. Now we're going to look at the options to squash and fix up. So squash and fix up are two super similar concepts that involve taking multiple commits and turning them into a single commit. So we can take 2 commits, or 3 commits, 4 commits, and we can combine them all together into a single commit. So as always, we're going to start here with a git status. You can see that I am still on branch mainline and I'm ahead of origin main by 7 commits. I'm going to give us a git log one line so that we can see what those commits are. I think these are the 2 commits that I want to combine into a single thing. So I have a commit where I replaced some boilerplate with that add method, and then I have a commit right after it where I changed the variable names in the add method. Now, those 2 things don't necessarily need to be separate commits, especially because I haven't pushed anything to origin yet. So I still have the opportunity to change these commits and combine them into one thing rather than have it happen, these 2 changes kind of next to each other. So in order to combine them into a single commit, we're either going to squash or fix up. And to do that, we need to enter an interactive rebase. It's git rebase -i for interactive. And that's going to open up our Vim editor. Remember that when we enter interactive rebase, our commit history gets turned upside down. So this is head down at the bottom, and then our commits get older as we go up the list. It always helps me to read this line here. It says that our commits are going to get executed from top to bottom. So we're going to be applying our commits down in this direction, from the top to the bottom. So we want to take these 2 commits right now, this replace Gradle init boilerplate with add method, and we want to take the commit right after it, change variable names in add method, and we're going to squash it into the previous commit. So the squash command is right here. It says use the commit, but meld into the previous commit. Squash and fixup are really similar. It even says that a fixup is like a squash, but fixup is going to discard this commit's log message and use the log message of the previous commit. So we're going to start with a squash. I'm going to down arrow to the commit that I want to squash into the previous commit. In Vim, I'm going to type DW to delete the word. And then I'm going to hit I to enter insert mode. You can see that I'm in insert mode down there. And I'm going to type S for squash, the space key to separate my command from my SHA-1 hash. This is going to squash that commit into the previous commit. And when it does it, it's going to give me the opportunity to decide what I want to actually call this commit. So I'm going to hit escape to exit insert mode, colon, and then WQ to write and quit in Vim. And this is going to take us into the squash editor to actually come up with the commit message that we want. It tells us what's going on here. It says this is a combination of two commits. This is the first commit message, and then this is the second commit message. And then it's saying enter whatever commit message you actually want to enter. So we have the text of both of them here. If we just hit I to enter insert mode and then put the hash character in front of this commit message, the only line in this file that's in play now is this one right here. It doesn't have that hash character in the beginning. It tells us right here, lines starting with the hash character will be ignored. So our commit message is going to be this thing. If I don't like that commit message for this, I can delete it and I can start over. I've actually been finding this a little bit confusing, the commit message that I have here. And so I'm going to hit escape to exit insert mode. You can see I'm no longer in insert mode down there. And then in Vim to delete a whole line, it's the letter D twice. I'm going to type D twice to delete the line. I to re-enter insert mode, and now I'm going to come up with my commit message. And I'm going to call this, using kind of the format that I've used for the other ones, introduce add method. That's going to be my commit message. Escape to exit insert mode, colon, and then WQ to write and quit in Vim. And I've now done that rebase. So we squashed one commit into another. I'm expecting that when I run git status, I'm going to see that I only have 6 commits now. So git status, I only have 6 commits because I took one commit and I squashed it into a previous one. And when I run git log -- one line, I can see that I have my introduce add method commit. I have my introduce subtract method commit, my introduce multiply method commit. So you can see from what we had before, these 2 separate commits, now I just have one commit. If I take that commit and I'm going to command K to clear my screen and then git show the SHA-1 hash of that commit, we can see that we've got the commit that is that combination of those 2 things together. So I'm introducing the add method, but I'm doing it with the variable names that I wound up using in the end. So instead of those variable names that we had that were A and B, this commit now just has all of that together. The new variable names, adding that the method, everything is combined into a single commit. I'm going to hit Q to quit out of that, command K to clear my screen again. I'm going to git log just one more time. So there we are, down to 6 commits. This commit is now that combination of those 2 earlier commits, and that is going through the squash process. The only difference in using the fixup process instead is that when we got to the point of doing the actual fixup, we wouldn't get asked to rewrite our commit message. It would just assume we wanted the first commit message, and it would just move on from there. So that's why I prefer using fixup to squash, but it's nice to kind of see the entire process if you do use that squash command. That's squash and fixup. So I don't actually want to do this on my main branch because I like the commits that I have on main, and this is going to be a destructive action where we actually combine all these commits into one. I don't want to end up in that state permanently, so we're going to move over to a branch to do this work. So I'm going to do a git checkout -b, and we're going to call this branch fixup for now. So you can see that we've switched over to branch fixup. I'll do a git status. We can see that we're on branch fixup. Our working tree is clean. I'll do a git log one line so we can see that right now on this branch, I have 7 commits that are sitting on top of my origin main or origin head commit. And this branch fixup is totally up to date with the branch main. So these two branches are actually currently the exact same thing. I am going to do an interactive rebase here against the origin main or origin head commit, and I'm going to fix up all of these commits into a single commit. Like I said before, I actually really like these commits. I think they're really nice and atomic. They're each about an individual thing. So this is really just for the purposes of demonstrating a larger fix-up. We're going to get rebase -I to enter the interactive fix-up. Oh, because I'm on a branch, Git wants me to rebase against a particular branch. I'm going to rebase against origin main. So we'll do git rebase origin main -I. There it is. So we're going to rebase against this commit down here, that origin main commit. So we're back into that interactive rebase space where we have all 7 of our commits that are sitting on top of origin main on our branch. And we're going to use the fixup command, the F or fixup command, to squash all of these commits and discard all of the commit messages and only use the remaining commit message. So what that looks like here, I'm going to leave this first commit alone. So we're going to actually squash everything or fix up everything into that commit. Everything below it, I'm going to use that DW keyword, the 2DW in Vim, to delete the word. So delete word, arrow down to delete the word. I'm going to do that all the way down until I've removed the word pick on all of those lines. I'm going to type I to enter insert mode. I'm going to start back up at the first commit that I want to fix up. It's F for fix up, and then the space key to separate the command from the SHA-1 hash. I'm going to down arrow and then F and space. There might be faster ways to do this. This is the way that I know how. So we've now prefixed these commits with that fixup command, all 6 of them. All 6 of these commits now are going to get fixed up into this first commit. I'm going to hit escape to exit insert mode, and then it's :WQ to write and quit in Vim. And we can see here with a git status and a git log 1 line, it's really the one that I want, we can see that we only have that one commit now. Here it is. It's called rename app.java to calculator.java. So the name actually is kind of misleading because it has a ton of work in it. We should probably reword that commit message. If I git show head at this point, or if I git show the SHA-1 hash of this commit, we can see that this commit now has all of our work in it, everything that we've done, everything that I did before you got here, all of that work together in a single commit. I'm going to hit Q to escape out of that. Command K will show that git log one more time. There it is, one commit. So we have fixed up all 7 commits down into just a single commit. This is really helpful if we've been kind of working incrementally, but we've only been working on a single idea. We're going to put out a single code review or a pull request for that one concept, and we wanted to get everything into a single atomic commit. So that is a more aggressive fix-up with more than just 2 commits. All right, we're gonna look at one more interactive rebase option, and that's the option to edit an earlier commit. So we know that if we wanna edit head, if we wanna edit the tip of the branch that we're working on, we can just run a git commit -- amend, and that's gonna amend the commit that's sitting at that head position. But if we have a commit that's earlier in our history that we wanna change, we need to do that with an interactive rebase. So as always, we're gonna git status. Right now I have 6 commits sitting on top of origin main. I'm going to run a git log 1 line to see what those commits are. And since we've been spending so much time with it, I'm going to go back to this particular commit where we introduced the add method. So this is the commit that I am wanting to modify. Now that I've had some time to think about it, I realized that it's a little bit strange that I named the variables here first and second, but then I named the variables here A and B. And so I've decided that I actually want to redo this, and I'm going to go back to having those variable names be A and B instead. In order to do this, I'm going to enter an interactive rebase. So it's git rebase-I for interactive. I'm in that Vim editor with the commits that I have. These are going to get applied from top to bottom. And this is the commit that I want to change, the introduce add method. I'm going to down arrow to that particular line, and then in Vim, DW to delete the word, I to enter insert mode, and we're going to use the command E or edit. So E and then space to separate my command from my SHA-1 hash. I'm going to hit escape here to exit insert mode, and then :WQ to write and quit. Now I'm in the middle of editing a previous commit. It says that I am stopped at this SHA-1 hash, so I'm stopped here at introduce add method, and I can amend the commit now with git commit amend, or if I'm satisfied with my changes, I can git rebase continue. I'm going to run a git status again here, just so that I can see a little bit more. If this stressed you out when it came up, I want you to know that it also kind of stresses me out. There's a lot of information here. So, but all of it's really helpful, and we can read it. We're smart people. So it says git status, and it says interactive rebase in progress. So anytime that we are in this state, we want to focus on the one thing we are doing, finish that work, and get out of this state. This is not a place we want to stay for a long period of time. It's telling us the last commands that were done, which is that it picked this particular commit, the rename app.java. So we can see that right here, rename app.java. It's the commit right before the commit that we are trying to edit. And then it tells us that we're going to edit this commit, the introduce add method. It's also telling us that we have some commands that are coming next. So after we edit this, it's going to try to pick these other two commits next. And then it's giving us some options of what we can do. So we can git rebase and then edit to do. We can git commit amend, or we can git rebase continue. Git commit amend and git rebase continue are the two that we're going to focus on here. I'm going to head over to IntelliJ and let IntelliJ catch up. You just saw that we lost our subtract and multiply methods. That's because right now those commits technically don't exist. They're going to get picked soon when we're done with our rebase, but at this moment in time, we are back in history. If I go to the calculator test file as well, you can see that my tests for those things are also missing. So that introduce subtract method and introduce multiply method right now, those commits just don't exist. So we're going to go to calculator.java, and I'm going to make the change that I was talking about. I'm going to change this to A and this to B. I'm going to change the variables here as well. And I'm going to put everything onto one line because it's really not that big of a method. So everything's on one line. That's the state that I want to be in. Before I commit this change, I want to make sure that everything still works at this moment in time as expected. So I want to make sure that my tests still run. And so I'm going to run Gradle test just to double check. Feel pretty confident, but I did change the method. I want to double check. So Gradle test passed. So my tests are still functioning. I'm going to give myself a git status again because I've changed the file and I want Git to tell me what I'm doing. So here we are. One more time, it says that I'm in an interactive rebase. I'm editing this introduce add method. I can git commit amend, or I can git rebase continue, and I have a dirty working tree. I've got changes that are not staged for commit. If I git diff, we can see what those changes are, right? That's the change that we just made here in IntelliJ. I'm going to add that to the index and then git status again so that I can see it in the index. So I've got my changes ready to be committed, and now Git is telling me that I can git commit amend or I can git rebase continue. Because I have changes, I need to amend that commit first. Sometimes it's helpful to ask Git what I'm amending, like where am I again, right? So if I git status here, I just did that. If I git log one line here, it's going to show me that my head right now is introduce add method. So that's the commit that I'm going to actually be amending when I run this git commit -- amend. I like to double check this stuff a bunch just so that I know for sure that I'm doing the thing that I think that I'm doing, because sometimes we can get a little bit lost here in these interactive rebases. So if I git commit amend, I'm going to modify this commit. Those other two commits are still out there kind of floating in space, the multiply and the divide, or the multiply and the subtract commits. So I'm going to amend this thing, git commit -- amend. There it is. It's going to give me the option to edit that commit message if I want to. I don't, so I'm just going to escape and then :right quit to exit Vim. And now I'm going to give myself a git status. Before I do that, I want to point out that our SHA-1 hash has changed. It says here that my SHA-1 hash was 86E. Down here, I've got a new SHA-1 hash that says C12. I'm going to git status so that Git can tell me where I am. Git says that I'm still in the middle of an interactive rebase. So I amended my commit, but I haven't actually moved on from that. If I wanted to, I could make more amendments to this same commit. I can actually create new commits and add them into my tree here if I want to. I'm not going to do either of those things right now. We amended the commit the way that we wanted to. We're done amending that commit. And so we can go ahead and git rebase continue. There it is. Same thing, I'm going to git status to see where I am. I have 6 commits locally. I'm going to git log one line to see what those commits are. So I have that introduce add method commit. We've looked at it a bunch. We just modified it. I'm going to command K to clear my screen and then git show that SHA-1 hash. So now that commit says that it's got the A and B variables. We had a moment in time where it had the first and second variable names, and now we've actually gone back in time. We've changed that commit so that the variable names are A and B again. We put everything onto a single line, and that's the entirety of the commit. It's the deletion of that boilerplate code and the addition of this add method. I'm going to hit Q to get out of this view, and then Command K to clear my screen. And I'm going to let IntelliJ catch up here. So IntelliJ was a little bit behind. We finished that rebase, and those 2 commits, the subtract and multiply commits, are now back. We can see that with that git log one line. We have the introduce add, introduce subtract, and introduce multiply commits are back where they belong. So that is a way that we can go back in time and edit some of our commit history. When we do that, we need to be a little bit careful of not editing stuff that's going to cause us a merge conflict. So this was really easy because all I did was edit stuff related to the add method. If I had also started to add a whole bunch of other stuff or got into some other areas and started to really muck around a bunch, then it might be really hard to apply these 2 commits on top of that work. So when we're doing that, we want to be really cognizant of what work we have staged where, what commits we have, where they are in what order, so that we don't cause ourselves a big merge conflict as we're going through this process. But if we can be really focused or really surgical about our changes, then we can go back in time and we can make edits to those previous commits. So that's a git interactive rebase using the edit command. If we are in the interactive rebase screen, all the way down at the bottom here, it says, if you remove a line here, that commit will be lost. Git doesn't use all caps very often, so they really mean it. It also says, however, if you remove everything, the rebase will be aborted. So if we're in this space here and I have typed DD to delete a line, so DD in Vim to delete a line, right now I still have that particular deletion in my paste buffer, so I can hit the P character to paste it back in. So I do this a lot to reorder commits, right? I delete a line and then I hit P to paste it back in somewhere else. But then sometimes I get a little carried away and I accidentally delete more lines than I intended to. If I remove a line here, that commit will be lost. So if I keep going with this, I'm actually going to lose my work. The way that we get out of this situation, since I no longer have all of those lines in my paste buffer, and I certainly can't remember how to type them by hand, it says, if I remove everything, rebase will be aborted. So I'm just going to go through and delete every single one of these lines. That's just the character D over and over to delete those lines. The lines that start with that hash character don't count. Those are comments, so they don't actually count. So now that I have no lines, I'm going to escape and then :WQ to write and quit. And Git's going to tell me there was nothing to do. So we didn't actually have anything to do. I aborted that rebase and none of my work was lost. If I git status, I have the 7 commits that I had when I started that rebase. I want to show you how to enter an interactive rebase when we don't have an upstream. So I'm over on a branch right now where I don't actually have this branch in origin. I haven't pushed this branch to origin. I'm going to do a git log one line here so that you can see it. So I'm on this branch called rebase no upstream, and I've got a bunch of commits here. If I do a git status, we can see that I'm on this branch. I don't have the line that tells me what I'm tracking upstream. So I don't have that line that says I'm ahead of origin by a certain number of commits, or I'm up to date with my origin branch. I'm just over on this branch. Origin doesn't know anything about this. If I try to git rebase here, Git's going to tell me I have a problem. So Git's going to say, hey, hold on a second. You don't have an upstream. I could set an upstream in origin if I wanted to, which I currently don't. I actually don't want this work to be up in origin. It's just for me. I can git rebase against a particular branch. So I could actually git rebase against my local main. Or I can git rebase against a specific commit. So again, I'm going to Command K here, and then we'll do that git log one line so that we can see the commits that we have. So I can git rebase against any one of these commits. Let's say that I want to git rebase interactive up to this point. So I want to have this as the last thing. That one's going to be set in stone. And then I'm going to actually rebase these 4 commits. So I'm going to copy that SHA-1 hash. It's a git rebase -I, and then it's going to be that name, that SHA-1 hash for this commit. And that's going to open up rebase for these 4 commits sitting on top of that particular commit. So git rebase -I. And now we can see that our interactive rebase to-do list here only has those 4 commits. So if you are over on a branch, you don't have an upstream, and you want to do some rebasing, we can do that. We just have to tell Git at what point in our history we want to stop. I'm going to escape, :right, quit to get out of that. And there we go. That's rebase without an upstream. Git revert command. So sometimes we've got a commit that we have pushed out to origin, and we realize after it's in origin that it is a mistake. I've definitely been there. I've pushed stuff that broke the build or caused some sort of regression. And when that happens, we just need to undo the bad thing, and then we can figure out what went wrong, and then we can create a new commit. So the easiest way for us to undo a commit is using the git revert command. So we're going to look at that now. As always, I'm going to start us with a git status so we can see where we are. We're on branch main. We are ahead of origin main by 6 commits. I'm going to git log one line, and we can see what those commits actually are. So in this initial commit, the only commit that I've actually pushed to origin, there's not much going on. If I git show that SHA-1 hash, we can see that I have added a file called readme, and it has the word readme in it. So not a very big commit, but let's imagine that this commit, I pushed it to origin, and then, oh gosh, it's awful. Something's bad. I just need to undo this thing. We're just going to revert it. It's a git revert, and then the SHA-1 hash of that commit, so that 21D number, 21D. And when I hit enter on that, Git is going to give me a commit message. The commit message here says revert, and then the commit message from the thing that I'm actually reverting. I think we're going to pause here for just a little second to talk about what a good commit message looks like. So we've talked in the past about how commit messages need to be capitalized in the imperative and no punctuation. The reason that we do that is because that's what Git models for us. When Git creates commits on our behalf, it follows that rule. So we're seeing here revert instead of reverted or reverting. So we've got that imperative, the command tone, capital letter on that first word, and then no punctuation at the end. I mean, in this case, we've got the quotes to quote the commit message itself, but no period or other trailing punctuation. So that's why we follow that particular practice for our commit messages, is because that's what Git does. So git revert, we revert that commit. I'm going to escape to make sure I'm not in insert mode, and then it's a :WQ to get out of Vim, and I'm going to git status here. We can see now that we have 7 commits. We used to have 6 commits sitting on top of origin main, but now we have 7. Command K to clear my screen. I'm going to git status and then git log one line again for us. So here we've got the original, that initial commit that's in origin. We can't change that. I can't get rid of it. It's already in origin. So the best thing that I can do is just revert it. We have a whole extra commit for where that revert happened. If I go now into my project structure and I look for it, and I try to open up this README file, we can see that there's just nothing there. It's a very interesting way. It took IntelliJ a minute to understand what had happened. So IntelliJ has now caught up, and IntelliJ is saying, wait a minute, I don't even have that file, because we reverted the entire commit. So that is a git revert, pretty easy and straightforward to do. All right, now we're going to look at the concept of a detached head. So we've talked quite a bit about the head commit, the commit that's the tip of the branch that we're working on. I am going to run git status for you so you can see that we have 7 commits here sitting on top of origin main. And then I'm also going to run git log one line. So in this case, we have our head commit, which is the tip of our local main branch. That's what this syntax here means. And our head commit is currently revert initial commit. We've got a bunch of other commits that are local, and then we've got our origin main and origin head commit all the way down at the very bottom. So to get ourselves into a detached head, we're going to git check out an arbitrary commit. The reason that I would want to do this is if I want to see locally in my IDE a particular state in time. So at one point, I initialized this empty Gradle application, and then I did a couple of things. I removed some comments, I renamed some files. So some things have changed since then, and I'm just curious about what things looked like at that moment. So I'm going to check out that commit. I'm going to enter that detached head state, and we're going to be really careful while we're in a detached head state to not make any changes that we actually care about. So I'm going to copy that SHA-1 hash. It's git check out the SHA-1 hash. When we enter a detached head state, Git is going to tell us all about it. So here it's telling us that we are in a detached head state. We can look around, we can make experimental changes and commit them, but we're going to discard any commits that we make here without impacting any branches once we switch back to a real branch. So we have to be really careful. If we start making changes and we commit them and we like our work, if we don't actually check out a branch for those changes, then we're not going to have those commits anymore. So there's the kind of that detached head state where they're just telling us exactly what's going on. I'm going to give us a git status down at the bottom. We can see the more abbreviated version. So here it just says head detached at this commit. So we're at this commit that starts with 03F. That was this one up here, 03F. Initialize empty Gradle application. I'm going to command K to clear my screen, and then we'll do a git log one line. So you can see right now we actually only have 2 commits. We have the commit that is origin main or origin head. That's the one that I've actually pushed out to GitHub. And then we have the commit that's sitting right on top of that, which is currently our head. We can see here that head doesn't point to anything. Before it said head, and then it was an arrow, it pointed to main. It said that we were on our main branch. Here, it just says head all on its own. That is a sign that we're on this detached head. I'm going to give IntelliJ a second to catch up. Oh, and you can see that actually my file's closed because the files that existed before when we'd done all of that work, those files didn't exist at this moment in time, at this initialize empty Gradle application moment in time. So if I open up the project structure here, I can see that I do have some files. I have an app file, and I have this app test file. This is what was automatically created for me when I initialized this Gradle application. So I've got a file called app, and it has a little comment in it. It has a couple little methods, so just some boilerplate stuff. I've gotten rid of this since, but this is just going back in time to the moment when I actually initialized the Gradle application. If I were to make changes here, let's say that I wanted to maybe add wanted to add a comment. This is the greeting string method. I would never actually do this. We don't comment methods that are self-describing, but let's just say that I did. I wanted to comment on that method. If I get status here, it's going to tell me again, I'm in a detached head state. So I'm not on a branch right now. I have changes that are not staged for commit, but I could technically stage and commit them. We're going to do it for fun. So git add app, get status to see that we actually have these changes now in the index in green. I'm still in a detached head state. If I git commit this, git commit -m, and it's just going to be add comment. Git status. It basically says that that commit doesn't exist right now. If I git log one line, I do technically have it, but because I'm not referencing a branch, I'm not seeing what I normally expect to see where it says like, oh, you have 2 commits ahead of origin mainline. So here we've got that commit. It does exist. If I go to checkout mainline, if I go to checkout main now, so I want to go back to my actual branch. When I do that, Git is going to say, hey, hold on a second, you're leaving a commit behind. So git checkout main, going back to my main branch, it says you're leaving a commit behind. It's not connected to anything. Here's the actual commit itself. If you want it, you need to check it out onto a new branch. So if I really wanted that particular commit, I need to make sure that I actually check it out onto a branch. In general, I would say it's okay for us to enter a detached head state to be able to look around at a particular moment in time. I would caution you against making any changes there because it can just get you into a difficult situation that can be hard to get back out of. But important to be able to know how to get into a detached head and then how to get back out of it. We just did a git checkout main. We're back out of that detached head. If I do a git status here, we can see I still have those original 7 commits. And if I do a git log one line, you can see that head is now pointing to main again. I've got my commit that's called revert initial commit, and the commit that I created about adding a comment no longer exists. So that's a quick rundown on detached heads. We're going to look at git push. So git push in my workflow at work isn't something that I actually use very frequently. We primarily merge our code through our web UI. We have a web UI. It's not GitHub, but it's very, very similar. And so normally we actually merge our code from there rather than from the command line. But I think that spending some time with git push can be really helpful. So again here, I'm going to give us a git status. We can see that we have 7 commits right now that are sitting on top of origin main. So those are 7 commits that are local to me. I haven't pushed them to origin yet. If I git log one line, you can see what they are. I am going to start by just pushing this one commit. So I have a whole bunch of history here, but I'm actually not ready to share all of it in origin. I only want to push this initialize empty Gradle application commit to origin. I feel very confident about that work. And so that's the thing that I want to share with my teammates. So in that case, what I'm going to do is run git push, and then we're going to give it a couple arguments here. So we're going to git push to origin. We're going to push that particular SHA-1 hash commit, and we're going to push it to the branch called main. So this should push that commit to origin on branch main. We're going to give GitHub a second to think about it. And now I'm going to git status one more time. And it says now that I have 6 commits sitting on top of origin main instead of the 7 commits that I had before. I'm going to command K to clear my screen here. And then I'm going to git log, you'd think I'd be able to spell git at this point, but git log one line. Here we go. You can see now that I've pushed that particular commit that this initial commit used to be called origin main or origin head, but because I've pushed this commit to origin main, now this commit is considered origin main or origin head. We're going to go through that exact thing one more time. So I've got this remove Gradle init comments. I'll show you what that commit actually is. Git show and then the SHA-1 hash of that commit. And this was just removing a couple of comments that Gradle had added to some files when I initialized Gradle. I'm going to command K to clear my screen, and then I'll git log one line again. So we're going to git push to origin this SHA-1 hash, the one that starts with 8B1, and we're going to push it to main. Git push origin, that SHA-1 hash to main. And then same thing, I'm going to give myself a git status. Now I only have 5 commits locally sitting on top of origin main because I pushed another commit out to origin. If I git log one line here, we can see that this origin main, origin head reference has moved up another commit. So it used to be down on initial commit, and then it was on initialize empty Gradle application. And now, because I've pushed one more commit, it's on this remove Gradle init comments commit. So that is one way that we can git push. I know oftentimes when you're new to Git, you just git push and it pushes everything. It's nice to know that we have some options to push just a portion of our commits rather than pushing all of our local commits at once. So that's a little more in depth on git push. All right, now we're going to look at Git branches. So if you've been paying attention so far, you've noticed that we have been on local main this entire time. I really want to encourage you to try to stay on your local main as much as possible. I just think that things are a lot easier if we are on local main. Our local main is going to be set up with origin main as our upstream, and it's going to be easier for us to rebase against what our coworkers are doing if we just live on our local main. I know sometimes beginners feel really nervous being on local main because they feel like there's a risk that they could do something that would impact the rest of their team or impact the production code. But your local main is a branch. It's not origin. It's a branch. It's your branch. And there's very little, almost nothing that we could possibly do here that would actually impact production code. It's possible, technically possible, that you could run a git push when you didn't mean to and push your work to origin main. And if somehow you really actually did do that, then we can use git revert or we can do some other things to reset history in origin. So let's not be afraid of that. Let's stay on main as much as possible. But there are reasons for us to switch to branches occasionally. And so if you've got a good reason that you really need to be on a branch, it's good to understand how they work. So let's just start, as always, with a git status so that we can see where we are. So we're here right now on our local main, ahead of origin main by 5 commits. I'm going to git log one line so that we can see what those 5 commits are. So our 5 commits, local commits, are these 5 right here. Everything's sitting on top of origin head all the way up to the head that's pointing to the main branch. So if we wanted to make a branch, we can do that here by running git checkout -b. You can see that my autocomplete wants to give me some branch names that I've used in the past. I was trying to make things really friendly to me, so my branch history includes a branch called Good Job. We're going to call this branch test. No, we're going to call it feature. No, we're going to call this branch, honestly, a lot of times I name them after myself. We're going to call this branch Alyssa. This is just a place for me to gather my thoughts. It's my little local branch. It's called Alyssa. If I do a git status here, we can see that we are on branch Alyssa, nothing to commit, working tree clean. But if you've been following along this whole time, you're used to seeing slightly more information when we run a git status, right? We have the git status for main right up here. It says that we're on branch main and also references our position in comparison to our upstream. So upstream is the branch in origin that we are working off of, that our local branch is always trying to stay up to date with. So in this case, the upstream for main is going to be origin main. Down here for this Alyssa branch, we actually don't have an upstream in origin. I haven't told origin about this branch, and I don't need to if I don't want to. So we can have branches that are just for us, that give us a place to play around a little bit without actually telling origin about those branches. Or we can tell origin about the branch. We could use that to share some changes with our coworkers, or maybe to do test deployments, those kinds of things. But for right now, we don't have an upstream branch, and when we run git status, we can see that that is missing. If I run a git log one line here, we've got a slight change to our commit history. So in our git log one line now, for this head commit, we can see that head is pointing to both Alyssa, the Alyssa branch, and to this main branch. So before, head was just main, and now head is currently Alyssa and main. These two are the same commit, and they're the head of both of these branches. So basically, these branches are currently identical to each other. We're going to go ahead and make some changes here, and we're going to see how that impacts the way that our git status or our git log one line looks. So since we still have this calculator, I'm going to go ahead and make a divide method. I'm just going to Command D to duplicate the line because I'm getting tired of typing it. And we're going to change this method to the word divide, and we're going to change this to the divide operator. I'm going to save that file, and then we'll go into the test as well. And same thing, I'm getting tired of typing, and so I'm just going to take the best shortcut that I can. Divide, we're going to call the divide method, and we're going to say that we expect the answer to be 2 if we have 6 and we divide it by 3. Obviously, we're going to run our tests. We can do that here inside IntelliJ, or we can do it with that Gradle, in my case, the Gradle test command. I'll do them both side by side. We can see IntelliJ succeeded with those 4 tests. Gradle on the right-hand side is just about done. Perfect. So small change, small test. We're ready to make a commit. I'm going to git status here. We can see that we are on branch Alyssa. We have changes that are not staged for commit. I'm going to Command K to clear the screen, and then git diff, so that I can actually see what those changes are. So it's just the addition of that divide method and the divide test. I'm going to git add both of those files, and then git status to see that my changes have been added to the index. And then we're going to git commit that particular thing, git commit -m. And in this case, we're going to say that we introduce divide method. Git status. So here we are on branch Alyssa. Same thing, nothing to commit, working tree clean. If I do a git log one line at this point, and actually I'm going to Command C to delete that, and then I'm going to clear my screen for us as well. If I do a git log one line here, we've got a new commit that's only on this branch. So we can see that we've got this commit called introduce divide method. That is the head of the Alyssa branch. We've got a reference to our main branch, which does not have this commit. The main branch only has the revert initial commit. Both of them have all of this. So the Alyssa branch has everything here. The main branch has everything below this. And then both of them are sitting on top of the same origin main, origin head. So we've got 2 branches. They're very, very similar. We've added 1 commit to the Alyssa branch. What do we want to do from here? So If we wanted to share this branch with our team, we could actually push this out to origin. When we do that, we're going to need to set up our upstream. So when I was running git status here, we can see that we don't have an upstream because it's not telling us what in origin we're referencing. So if we want to push this, we're going to git push and we're going to set the upstream. So we're going to tell git what our upstream branch actually is. The first keyword here is that we're going to tell it where. Where is going to be origin. And then the second word here is going to be the name of the branch in origin. I always like to name my branches the same thing locally as they are in origin, but that's just a convention. We could actually name this anything we wanted. So we could make the branch called banana up in origin and use that as our upstream. I'm not going to do that. I'm going to use my name again. So I'm going to git push all of that to that branch in origin. Git has told us a whole bunch of information. It says that we've got a new branch. It says that branch is Alyssa, that's my local, pushing to Alyssa, that's the one in origin. And it says that branch Alyssa is set up to track remote branch Alyssa from origin. So now if I do a git status, we're going to see that my local branch Alyssa is up to date with my origin Alyssa branch. So I'm up to date with my upstream branch, the one that's in origin. I'm going to, let's see, we'll clear the screen here. And I'm going to go make a file. Actually, a while ago, we'd made a directory called notes, and then we touched a file in there. And then I actually had wound up deleting that commit. I'm going to recreate that for us. So we've got this little change. I'm going to git status on that. And we've got a new directory called notes that has a file in it. If I git status with a u-u, it'll show us actually the entire path there, including the name of the file. I had a link that I wanted to share. I'm going to go find that for us right now. It's the Chris Beam's guide to commit messages. And it's something that I want you to take some time to actually read on your own. So we'll put it into this links to share file for ourselves. We're mostly just doing this so that we have some new commits to work with. So I'm just going to do this in Vim because I don't feel like going to IntelliJ. We're going to Vim that, that's not where it is. We're going to Vim the file, notes, links to share. I'm going to hit I to enter insert mode. This is Markdown, so I'm going to give this file a title, links to share, really original. And then I'm going to give myself a bullet point and I'm going to paste in that Chris Beam's link. So there it is. Spend some time reading that. Escape to exit insert mode : and then WQ to save that file. If I give myself a git status -u, again, we can see we've got that file, still an untracked file. Command K to clear my screen, and then I'm going to do a git diff so that we can actually see it. Oh, sorry. What I mean here is git diff head. I don't mean that either. I'm going to add the file. And then I'm going to git status. There it is, not screen. And now I'm going to git diff head. So we can see that we've actually added the file. So I've got the file in index. We can see that we've actually added a new file, and then we can see what the file is. It's just this little links to share file. And I'm going to commit that, git commit -m. And we're going to call this create links to share file. Great. I'm going to give myself a git status so that I can see we've got one commit now. So we're still on branch Alyssa, but our local branch Alyssa is ahead of origin Alyssa, the upstream branch, by one commit. Command K to clear my screen, and then we'll do a git log one line. And so here, now we have a lot going on. We have our last commit that's on origin main, so that's the last commit on the main branch that we've pushed to origin. We have a whole bunch of local commits. All of these commits are on the main branch. We see that main keyword. All 6 of these commits are pushed out to origin on the Alyssa branch. And then this 7th commit here is local to the Alyssa branch. It's not in origin and it's not on main. So we've got an introduction to branches here, and we've spent a little bit of time reading that git log to understand what all of these different things mean. As you can tell by adding a branch, we're adding quite a bit of complexity to our git system, and that's part of why I recommend that when we can, we just stay on main all the time. But if you need to be on a branch, it's really important to actually understand all of the inner workings of how that actually goes. So there's a quick intro to git branches. This can be really helpful if we have a development branch that we are regularly pushing stuff to, and we want to be able to rewrite the history of that development branch. I use this to share work with coworkers and then just obliterate that work and share different work instead. So we've got a branch here. If I git status, we can see that we're on branch Alyssa. We're ahead of origin Alyssa by 1 commit. If I git log 1 line, we can see that we've got a commit in at origin Alyssa. We've got another commit actually sitting on top of that locally. So all 6 of these commits have been pushed to that origin Alyssa branch. This commit hasn't been pushed to that remote branch yet. I'm going to show you how to delete that origin Alyssa branch because we want to maybe push totally different changes to that branch, or we just don't want that work hanging around. I like to be really careful with the branches that I have in origin. I don't want to make origin into a gigantic mess that has a whole bunch of branches that we've abandoned. And so I want to make sure that I'm kind of cleaning up as I go. So to delete a branch in origin, I'm going to show you the way that I know how. That's going to be a git push. So we're actually going to push to origin, and we're going to push nothing. So git push origin. And then we have this syntax. You can actually see that my command line is trying to fill it in for me, where we have a SHA-1 hash and then the name of the branch. So we can use that syntax to push a specific commit. If we don't put a SHA-1 hash here and we just use the colon in the name of the branch, that's effectively going to delete the branch. So I'm going to show you what that looks like. It's just a command and then the name of the branch, Alyssa. And when I do that, we're going to see that response from GitHub saying that I've deleted that branch. If I do a git log 1 line now, we can compare the output here to the output above. We can see that before we used to have this commit origin Alyssa. And now we can see that that particular commit, that introduce divide method commit, is actually no longer in origin Alyssa. That branch has been deleted. If we do a git status, we can see that we're on branch Alyssa, but origin Alyssa, the upstream, is gone. So Git knows that we've deleted that branch in origin. If we want to fix things on our side and let Git know, hey, yep, I know that branch doesn't exist in origin anymore, we can run git branch unset upstream. And now when we run git status, we're going to be back to this place where our branch actually does not have an upstream. So that's a way that we can delete a branch in origin if we want to be able to reuse that branch for a different purpose, or we just don't want that work out in origin anymore. Now we're going to learn about git cherry pick. So sometimes we're in a situation where we have work on a particular branch and we want to bring it over onto a different branch. I like to do that using a git cherry pick. There are lots of other ways that we can do that, but I think cherry pick to me is the one that is the easiest to understand. So I'm over here on this Alyssa branch. I'll show you with a git status. We can see that we're on branch Alyssa. If I do a git log 1 line here, we can see that the Alyssa branch is 2 commits ahead of main. We're going to cherry pick one of these commits to bring over to that main branch. So the one I'm going to focus on is the one that's sitting on top here, this head commit with that SHA-1 hash that starts with E65. I'm going to copy that SHA-1 hash and I'm going to switch over to the main branch. I'm going to give myself a git log one line here just so that I can see it. We've got our head pointing to revert initial commit, and we're going to cherry pick the head of the Alyssa branch that create links to share file. So the command here is just git cherry pick, and then the SHA-1 hash of the commit that we want to pick. I'm going to hit enter on that. It's going to tell me that it did it successfully. If I get status now, before we had 5 commits, I'm expecting now that I'm going to have 6 commits. I'm going to command K to clear my screen and then git log one line. We can see that we now have this create links to share file commit as the head of our main branch. I'm going to do that one more time. So if we go back to the Alyssa branch, and we git log one line here. One thing that might jump out to you if you were looking really, really closely is that previously we had a reference to our main branch in the git log one line output of the Alyssa branch. And that's because those two branches shared perfect history and the Alyssa branch just had some stuff sitting on top of main. They now no longer share perfect history because we have this create links to share file commit, but main is actually missing this introduce divide method commit. So because they don't share history all the way back anymore, we don't see that reference to main on the Alyssa branch at this moment in time. I'm going to cherry pick this commit now. So I copied that SHA-1 hash. I'm going to go back to main, and we see that we have 6 commits, and I'm going to git cherry pick this SHA-1 hash. When I get status, we'll see that we have 7 commits now. Command K to clear my screen, and then git log one line. We can see that we have both of those commits. I chose to cherry pick them out of order just to show you that you can do that. So we cherry picked that links to share file commit first, and then we cherry picked the divide method second. So now I have both of the commits from the Alyssa branch over here on the main branch in the reverse order. That is a quick intro to cherry picking. I want to take a minute to put a bunch of that together. We're going to do a lot of those things that we just saw, but we're going to do them all at once. So first thing, as always, is a git status to see where we are. I'm currently on branch main. I'm ahead of origin main by 7 commits. So in general, I'm not going to be sitting with 7 commits locally that I haven't been code reviewing and pushing out to origin. We're going to clean this up a little bit, and we're going to push some of these commits and get us back into an even better state than we're currently in. So I'm going to git log one line here so that we can see what we have. So I can see that we have pushed this this remove Gradle and init comments commit out to origin. We did that together. And then we've got these 7 commits that are sitting on top of that origin main commit. I like some of these commits quite a bit, and I'd like to push them out to origin. Some of these commits I'm not ready to push. Some of them I actually want to get rid of, and some of them I want to reorder. So this revert initial commit that we did together, where we actually reverted the first commit of the package, I don't want to keep that. I'm going to delete that particular commit. These 2 commits, I'm going to change their order. We've got the introduce divide method, and then we've got this create links to share file method. I'm going to reverse the order of those 2 commits because I want this divide method to go down here with the other methods that we added, so that we have all 4 of them together. And also, I'm just not done with this commit. That create links to share file commit, we put 1 link into it. I'm not actually done with that. I'd like to just save that as a work in progress and maybe move it over to a branch for later. So we're gonna do all that together. So we're gonna do this with an interactive rebase. Git rebase -I. Like I said, I want to delete this commit. The revert initial commit, we just did that for fun. I don't want any more. If I remove a line, that commit will be lost. So I'm gonna delete that. Now it's gone. This one, I said I wanted to move slightly higher up in the list of commits. So I'm going to hit DD to delete this line, and I'm going to move it up to go right underneath that multiply method. So I'm going to hit P in Vim to paste what's in my paste buffer. There it is back again. So now I have these commits in the order that I want them in. Introduce add method, introduce subtract method, introduce multiply method, and then introduce divide method. This last commit here, I'm going to turn that into a WIP commit. And I like to mark my WIP commits for myself, WIP being short for work in progress. I like to mark those commits for myself just so that I can remember I was in the middle of something here. I'm not actually done with that work. So I'm going to reword this commit. It's DW in Vim to delete the word, I to enter insert mode, and then it's the letter R for reword, a space to separate the command from my SHA-1 hash. So now we've got this commit here with that reword command in front of it, and Vim's going to give us a chance, or Git, sorry, is going to give us a chance to change that commit message. I'm going to hit escape to exit insert mode, :WQ to exit out of Vim and save my work. Like I said, Git's going to give us a chance to change this commit message. I like to prefix my WIP commits with the square brackets and then the word or those letters WIP right there. So WIP for work in progress. I'm not actually done with this piece of work. So now I can remember that. It says that it's a WIP and I won't forget that this thing isn't actually done. Escape to exit insert mode, and then WQ. I'm going to hit enter and it's going to complete the rebase for me. Now that we're done with that rebase, I'm expecting that I only have 6 commits because we actually did delete a commit together. So we're going to do a git status here to see that we only have 6 commits. I'm going to command K to clear my screen, and then it's a git log one line so that we can see those commits. This is beautiful. So we've got origin main down here, the last one that we've pushed to GitHub. We've got a commit where I renamed a couple files. We have the introduction of each of our methods separately as separate atomic, really beautiful, tiny little commits. And then we have this WIP commit sitting on top. I feel great about this work. We can even pretend that I've put it through code review and my teammates have approved it. So all the way up to here, I feel really good about that work. I'm ready to push that into origin. So we're going to copy that SHA-1 hash, and then it's going to be a git push origin and the SHA-1 hash that I want to push all the way up to. Remember that I can use the SHA-1 hash here, or I can use that referential head. We can do a head ~1 to refer to this commit. So again, 0, head ~1, head ~2, etc., all the way down. I've got that SHA-1 hash in my paste buffer, so I'm going to go ahead and paste it. We're going to push that to main. So git push origin up to what point? Up to that point, out to the main branch. I don't typically actually push to main. My workflow uses a UI where my teammates merge my code into our main branch. But this is one way that we can do it on our own, especially when we're working on a project that's just for us. So git push origin, what we want to push up to, and then main. I'm going to give GitHub a second to spend some time with that. So we can see that we have push this to GitHub. It looks like everything went perfectly smoothly. I'm going to give us a git status now, and when I do that, I expect that we're going to see one commit sitting on top of origin main because we pushed everything up to here. So this last commit is not going to be in origin main. Everything up to here will be, so we'll have one commit ahead of that origin main. Git status, we see that we have our one commit. If I git log one line, same thing. I'm going to see that this reference to origin main has moved all the way up to this introduce divide method because that commit now is out in origin. The only commit that's not is this very last one, the WIP. So git log one line, we can see exactly what we expected has happened. The reference to origin main or origin head has moved all the way up to this introduce divide method commit. We have one commit sitting on top of that. I'm going to command K to clear my screen, and then I'm going to just git status and git log one line. I know it was just there. I just really like to see it. Okay, so there we have it. Git log one line. this whip commit, I'm actually going to change ideas right now. So I'm about to move into some stuff related to setting up a gitignore, and I'm just not done creating this links to share file. I've got more stuff I want to put into it. I'm not ready to commit it. I actually just want to get it out of my way for the next tutorials that we're going to do. So I'm going to go ahead and move that over to a branch for myself, and then we're going to come back here and delete it off of this branch. So I'm going to move it to a branch. Oops, sorry, it helps if I use the right commands, right? Git checkout -b, and we're going to call that branch notes because that's what this, I had a directory in here that was called notes. This is where I'm putting my notes. So I'm going to put that over on that branch. We can see that we've switched to the branch. If I git status, it's going to tell us I'm on that branch. If I git log one line, I can see that I've got this commit on the notes and on the main branches. Everything else looks exactly the same as it did up here. Now I'm going to actually go back to my main branch. I'm going to command K to clear my screen. We'll git status one more time here. So we have that one commit that's sitting on top of origin main. I'm going to git log one line. Like I said, I decided I actually don't want this on my main branch anymore because I'm going to do some other work on my main branch that's not related to creating these notes. And I just want that commit out of my way. So I'm going to reset hard to this commit. We can do that again a couple different ways. So I can git reset hard using the SHA-1 hash. I can use the reference to origin main or origin head since that's what that commit currently is, or I can use that head -1 because that is another name for this commit, 0, 1, 2, 3, etc. So I'm going to use the SHA-1 hash. I like using the SHA-1 hash just because it's so specific, and then I know for sure that I have the right commit. So I'm going to git reset hard to that SHA-1 hash. When I do that, this commit is going to go away on main. I'm not going to have it on main anymore. We can see that head is now at that SHA-1 hash introduce divide method. If I git log, or rather if I git status, it's going to tell me that I have no commits sitting on top of origin main. So I'm going to be up to date with origin main on this branch. Perfect. I'm on branch main. My branch is up to date with origin main. If I git log one line, we can see that introduce divide method is now all of those things. It is the head of my local main, its origin main, and its origin head, right? And the commit that was sitting on top of it here is no longer on my main branch. That's exactly what I wanted. I'm going to command K again to clear my screen. And then if you're having a moment here where you're like, wait, Alyssa, I thought we wanted that commit. Where did it go? We put it over on that branch for ourselves and it's still over there. So if I go and I check out my notes branch, and then I git status here and I git log one line, we can see that the notes branch still has that commit. So I haven't lost it. I've just set it aside for myself. When we set work aside, we want to be really careful about what work we're setting aside and how that's going to maybe interact with the next work we're going to do on a different branch. So in this case, this particular commit only has changes about creating a new file and adding some notes to it. So that work is really over on the side, totally separate from any of this like Java work that we might be doing together. And so I know that that work is not going to wind up creating a merge conflict with the work I'm about to do. We want to be really careful about not setting ourselves up for a merge conflict because merge conflicts are really taxing. They're very hard on our brains to get back through our work. It's basically just duplicating work we've already done. So when we're setting something aside, we want to make sure that it's a good thing for us to set it aside. This is a piece of work that doesn't play with anything else. It's going to be a fine thing for us to set aside. I'm going to go back to that main branch. So git checkout main, git status. Perfect. So this is the state that I want to be in as much of the time as I possibly can. This is a beautiful state. It says I'm on branch main, I'm up to date with origin main, nothing to commit, working tree clean. Everything that I have here is perfectly clean. I don't have any stray work. I don't have anything that's going to accidentally interact with something. I'm not in the middle of two different thoughts simultaneously. I'm in this beautiful, clean working state, and it means that we're ready to start working on our next task. So you can see over on the left-hand side in my project tree that I have a file called gitignore. This is a list of files or directories that I want Git to just completely ignore in this package. We don't want to track these things. There's some really obvious candidates for inclusion in a gitignore. In my case, because Gradle is my build tool, anything in this Gradle directory, we don't want to commit that. And then another one here is going to be that build directory. These are all artifacts of me running local builds, and we're not going to commit any of these things. So luckily, when I initialized this Gradle package, Gradle set up my gitignore file for me. But we're going to go through and we're going to delete some of the things in here and see what that impact is, and then we're going to put it back together again. So first thing, as always, is just a git status. We are on branch main. We're up to date with origin main. This is the place I want to be as much as I possibly can. If I git log one line, we can see that we've got some commits that are out in origin, but everything is totally up to date. Main, origin head are all pointing to the same commit. Now we're going to go through and actually delete some stuff in this gitignore. So I'm going to get rid of the .gradle in the gitignore file. And when I do that, I'm expecting that I'm going to see that the .gitignore file has changed. And I'm also expecting that Git is going to try to pick up this Gradle directory. So I'm going to git status here, and we can see that Git knows that I've modified the gitignore. And then it's also saying, hey, I have these untracked files. This .gradle directory is full of untracked files. Sometimes I will see beginners leave stuff in this untracked files state on purpose for a really long time. So they know they've got stuff that they don't want to track, and they just leave it here in this persistent untracked file state. When we have stuff in the untracked files area, it's not possible for us to get to this state. Nothing to commit, working tree clean. So we don't want to be hanging out with stuff in this untracked files area intentionally for a long period of time. We always want to be telling Git, hey, if I don't care about it, I don't want you to care about it, please just ignore this. So here we are, we've got the change to the gitignore, and we've got the change to the untracked file here. If we catch it right away, we see that we have untracked files and we definitely do not want to track them. If we catch it right away, we can go back to our gitignore and we can put that .gradle, in this case, into the gitignore, and we'll be back into our perfect little state. So I'm going to come back here and I'm going to add that .gradle directory back into my gitignore. Perfect. I'm going to save that file. And now if I come back to my terminal and I git status, perfect. That was it. So we added it back to the gitignore. We're ignoring that Gradle directory. Everything super easy. That was great. So we saw it right away. We fixed it right away. Sometimes what happens is that we don't fix our untracked files issues immediately, and we wind up in a more difficult state. So I'm going to show you that state. I'm going to Command K to clear my screen. I'm going to delete that Gradle line out of my gitignore again, and we're going to see that we have the gitignore change and this untracked files. So let's say that I now did a git add all. I was just a little bit heavy-handed, I was moving too fast, and I added everything, including those Gradle files, to Git. So git add all, and then a git status here. This git status is not going to be great. In my git status, oh gosh, I can see that my changes to be committed include everything in that Gradle directory. That's a whole bunch of stuff that I really don't want Git to know about. So let's say that it's at this moment that I realize I need to add something to my gitignore. I'm going to go back to the gitignore and I'm going to add the .gradle to it. Perfect. I'm going to save that file. And now I'm going to come back here and I'm going to do a git status. When I do this git status, I'm really hoping that Git will just ignore everything in the gitignore. So we'll do a git status and we'll see if that works. Gosh, it didn't. We can see that we've got the modification to my gitignore down here. So we know that Git has picked up this change. Git knows that I've added .gradle back to it. But because all of these files are in the index and staged to commit, Git's not going to just automatically get rid of them. Git's not going to take them out of the index for us. So if we're in this state where we've accidentally added something to the index and we don't want it in the index, we actually want to ignore that file, we need to tell Git to forget about it. So that's going to look like this. It's git remove -r. The R here is for recursive, so it means that we're going to remove everything that's inside the directory. --cached. Cache was the original name for the index, and sometimes we see a little bit of a back and forth in the word there. So we're going to remove this stuff in the index using the cached flag. And then we tell Git exactly what directory we were talking about. So with that recursive flag, we know we're talking about a directory. It's going to be everything inside a directory. And here we're going to tell Git that we want to recursively remove everything from the index inside that Gradle directory. So there's the whole command together. I'm going to hit enter on that. We can see that we have removed all of those Gradle files. If I git status now, this is a little bit confusing, but I've got a gitignore that's partially staged and a gitignore change that's actually just in my working tree. This was the deletion, and then this is the addition of that Gradle line. So if I do a git diff here, we can see that it's trying to add Gradle back in. If I do a git diff head, which is going to show me the changes that are in the index and in the working tree, it's going to actually say that there's nothing here. So git diff head, there's just nothing there. This was the removal of the Gradle line. This was the addition of the Gradle line. If I add my gitignore, so git add dot, and then git status, we can see that we're back into that perfect state, nothing to commit, working tree is clean. So that was two ways that we can add something to the gitignore. If we catch it right away, then Git is just going to leave us alone. And if we accidentally add files that we want Git to ignore, we're going to have to tell Git to forget about that with that git remove and then that cached flag. Git config is one of the plumbing commands. So if you remember at the very beginning, we talked about the porcelain and the plumbing commands. So it's a little bit deeper in the weeds. It's not something that we touch every day, but it's helpful to know what it is and how to interact with it. So if we run a git config -- list, Git will just output our config for us. So this can be a little bit overwhelming to look at first, but basically what we have here are some key value pairs. The first piece of this on the left-hand side of the dot is going to be the scope. This itself on the right-hand side of the dot is the actual key. And then this is the value. So we just have a list of key value pairs with some different scopes to them. We see the scope user, the scope core, the scope remote, and the scope branch. We're going to look specifically at the user piece of this because sometimes you need to make changes to your user, how you actually identify in Git. I also want to point out this one down here, the core.excludesfile. So we looked previously at a packages gitignore. It's actually over here on the left-hand side. This is the gitignore for a package. I actually also have a gitignore for myself. This is my personal gitignore file, and we'll look at that in a second. But the first thing I want to do here is just change something about my own git config. So let's say that we want to change our name in Git. To do that, we're going to do a git config. I'm going to use the global flag here to change my name globally, and I can keep typing. We're going to use the scope user and that keyword name, and then we're going to change it to something besides just my actual name. I'm going to change it to my name plus that funfetti emoji just because it's fun. I'm gonna hit enter on that, and then we'll do a git status. No, sorry, we'll do a git config list. You can see git status is just built into my fingertips at this point. So git config list, and we can see that I have globally changed my actual name in Git. So from now on, when I make commits, this is the name that's going to be associated with it. I'm going to command K here we'll do a git status and a git log so that we can see that my old commits haven't changed. They still have that old author name without that emoji. Q to quit out of this, Command K to clear my screen. I'm going to just change something arbitrarily in here. There's got to be something small that we can make a little edit to just to make a commit for fun. This is just a comment. I'm going to get status to see that we've added that comment. It's not staged for commit yet, so I'm going to stage it for commit, and then I'm actually going to commit it. -m, add a comment. I'm going to get status. We can see that we actually did add that commit. Command K to clear the screen, and then a git log. You can see that now that I've changed my global username, that the emoji is actually showing up in my authorship. So if you need to change your name or your email address or anything else about what Git knows about you, we're going to do that by changing stuff in our Git config. I'm going to Q to close out of this, Command K to clear the screen. I actually don't want that commit, so I'm going to git reset. We'll do it the long way. Git status, git log, one line. I want to reset to this commit, so I'm going to git reset hard, and we'll do it actually referentially with that head -1, git reset hard head -1, git status. We can see that we deleted that particular commit. If I git config list one more time here, let's say actually I changed my mind and I don't want that emoji in there anymore. That's going to be a git config -- global user.name, and then I'm going to change it back to just my actual name, git config -- list to see it, and we can see that we've undone that change. So it's a quick introduction to git config. I encourage you to read through the rest of your config. Yours probably doesn't look quite the same as mine, and just familiarize yourself with that and make any changes to it that you might want to make. So in a previous section, we looked at a package gitignore. That's going to be a gitignore file that applies only to that particular package or repository that we're working with. A global gitignore is going to be a gitignore that's ours, that belongs to us, that we can put anything into it that we want, and it won't actually impact anybody else. It only impacts our own Git workflows. We also looked at our Git config. So it's the Git config that's going to contain the reference to our global gitignore. I've gone through and actually deleted my personal gitignore, and we're going to recreate it together. So the first thing I want to do here is take a look at my Git config. So if you remember from that previous section, we had a line in here that said core excludes and then a reference to my my personal gitignore, my global gitignore file. I've deleted that reference entirely, and I've actually deleted the file. So if I do a git status now, we're going to see a reference. We're going to see that Git is looking at some stuff that it wasn't looking at before. So git status shows us that we have in my untracked files, I have this .idea directory. .idea is an IntelliJ artifact. So it comes from the fact that I'm using IntelliJ, and the fact that I'm using IntelliJ is a personal decision that I am making as a developer. So my coworkers might not be using IntelliJ. They could be using VS Code or some other IDE. And so because this is specific to my workflow, we want to add this to my gitignore. It can be tempting to add this to the packages gitignore, but the idea stuff, this .idea stuff, really is not related to the package. It's related to me, so it belongs in my personal core excludes file, my global gitignore. When we were adding stuff to the packages gitignore, we added this Gradle directory. Gradle, in this case, is actually an artifact of the package itself. Gradle is the build tool that I'm using here, and so we want anyone who's using this package, to automatically ignore those Gradle files. That's why we put Gradle in the packages gitignore. We're not going to put the idea stuff in that. We're going to put it into our own core excludes file. So to do this, first of all, how do we know that we need to do this? We know we need to do this when we see that we have untracked files that we know we want Git to ignore. So I never want us to have persistent untracked files that are just hanging out forever that we're always trying to skip over and not accidentally add to Git. Anytime that you see something in here that's untracked and you know that you want it to remain untracked, it needs to go into a git ignore file, either the global or the package gitignore. So that's how we know we need to do something, is that we've got this untracked file. I'm going to do a git status -u just so you can see what's actually inside that directory. So we have a whole bunch of XML files. Git status -u is going to show us everything underneath the untracked file directory. So we've got the Gradle, we've got this jar repository, we've got this workspace XML. So all of this stuff is just related to my use of IntelliJ. I'm going to Command K to clear my screen, and we're going to start by actually making the excludes file itself. So typically this excludes file is going to be in my home directory, and it's called .gitignore, but you can put it wherever you want as long as you know where it is. So we're going to touch .gitignore in order to create that file in my home directory. And then we're going to actually open it up. So I'm just going to vim that file. The file here is actually empty. We just created it. I'm going to hit I to enter insert mode, and I'm going to add back the things that I have always had in my gitignore. My global gitignore is usually pretty small. It has stuff that's specific to IntelliJ, so it's going to be a star.idea. So it's going to be anything that ends in .idea. It's going to be a star.iml. Those are other IntelliJ files that can get created in some circumstances. So star.idea, star.iml. And then I've always had a build directory listed in my own gitignore as well. You can see that we have the build directory here in this package gitignore. I'm going to just put this back because that's how I always had it. So I'm going to hit escape to exit insert mode here in Vim, and then it's a :WQ to write and quit. Just for fun, we're going to cat that file back to the screen so that we can see it. So cat is just short for concatenate, and in this case, it's just going to display that file. Oh, we have two. Cat and then gitignore. We can see that we have some entries in the file now. We've got the star.idea, the star.iml, and the build. If you're not using IntelliJ, don't add these things to your own gitignore. Only add stuff that's actually important for you. So here we've created the gitignore. If I do a git status now, we can see that we still have idea in that untracked files area. And that's because we haven't actually told Git about the gitignore file. So even though we made it, Git is not aware of it. We need to update our git config to reference that file. So to do that, I'm going to run a git config using the global flag. And we're going to set the core excludes file. Oh, you can see that I've got an auto-completer here that wants to complete this for me because I've done this before. So we can see exactly the command we're going to run. It's a git config -- global core.excludesfile. That's the key. Helps if I spell it right. So the scope is core, and the key itself is excludes file. It's a space, and then it's the location of the file. So my gitignore file we made together is in my home directory, and then .gitignore. That's the file. I'm going to hit enter on that. And then just to make sure that it happened, that it actually worked, I'm going to do a git config -- list. And we can see that the core excludes file has been added back into my git config. So the scope is core, key name is excludes file, and then here is the actual value, my home directory, and then the .gitignore. I'm going to Command K to clear my screen. And then if I do a git status here, you'll see that we are now ignoring that .idea directory. So we're back in this beautiful state. It says that we're on branch main. My branch main is up to date with origin main, nothing to commit, working tree clean. So this is where we want to be all the time. If you've got those untracked files, they're hanging out, we need to decide where they're going to get ignored, either in our global gitignore or in the package gitignore. And then we need to immediately update those things so that we no longer have those files or those directories hanging out in our working tree, making our working tree dirty. So there we go. That was a global gitignore file. So the first thing that we're going to look at is a scenario where we have accidentally created a commit locally that contains things that we just don't want inside that commit. So the first thing we're going to do is get ourselves into that pickle. I'm going to start by removing the .gradle directory from my package gitignore, just so that we have something that we know we really don't want in this commit, right? We don't want this in the end to be actually in our commits, but we're going to put it there on purpose. And now I'm going to move over back to our calculator, and I'm going to give us a new piece of work that we actually care about, that we actually want. And I think that's just going to be the mod operator. So we're going to do a public static int mod, and that's where we use the modulo. And I'll make us a little test for that as well, since I like when we have a test to go with our work. So here we go. Perfect. Mod. And then what do we actually expect? If I do a 7 mod 3, I expect that to be 2. I'm pretty sure. Again, anytime that we make changes, we want to make sure that they actually work. So I'm going to run Gradle test over on this side and make sure that my tests pass. That looks great. So I think our test actually worked. I'm going to do a git status here. We can see that we've got changes to the gitignore. That was me removing .gradle. We've got changes to the calculator, and then we have these untracked files. So let's say that we're just a little bit out of control here, and we have added everything. Git status. Oh my good gosh. We've got all of the stuff in that Gradle directory. We've got the changes to the gitignore. We've got the changes to the calculator, and I'm going to commit it. So here we are in this state, git commit, and really all I thought I was doing was just adding that that mod method. So we're going to do introduce mod method, and I'm going to do a git status. Perfect. So down here it says that we have one commit sitting on top of origin main. I'm going to git log one line. That looks good. So we've got our one commit, but again, if I git show on that commit, oh gosh, we can see that we have a lot of different things going on. We've got these binary files, we've got the deletion to the gitignore. Our commit itself has a whole bunch of stuff in it. Oh my goodness. Oh, good grief. And then we actually do have in there the stuff that we actually wanted. There's the actual content of the commit, but you can see that we accidentally committed that Gradle directory, right? So we're in this state right now where we've got the one commit, but the commit has stuff in it that we really don't want. For me, if we're sitting here with just that last commit is the one that we want to modify, the easiest thing for us to do is going to be a soft reset back to origin main, so that we basically remove the commit without deleting the work. So I'm going to do that right now. We're going to do a git reset, not a hard reset, just a soft reset. And we're going to do that actually just to origin head. So we can refer to this commit here as origin head, origin main, or that SHA-1 hash, head ~1. They're all the same thing. And that's going to uncommit the commit without actually losing the work. Git reset to that point. It's going to tell us that we have unstaged changes after the reset with the gitignore and the calculator test. I'm going to do a git status here to see what we have going on. Perfect. So we're back in this state now where we've got our gitignore, we've got the changes to the calculator, we have these untracked files, we've remembered now, oh my goodness, I need to add that .gradle to my gitignore so that I stop accidentally committing the thing. So I'm going to go back to my gitignore file. We can actually see that IntelliJ is offering us that little blue arrow. I like this one, little blue square that gives us this left hook arrow to roll back these lines. So I'm going to bring back my .gradle in my gitignore. I'm going to come back over here to git status. Perfect. So we can see that the untracked files, that .gradle directory, is now gone. Git is ignoring it, which is what I wanted. I only have the changes to calculator and calculator test. If I git diff on that, we can see that it's just that new method and the new test. We're going to recommit that, but of course, before I recommit, I want to make sure my tests still pass. Perfect. Thanks, Gradle, for running those tests. I'm going to do a git status. Again, I'm just obsessed with git status. Do it all the time, we're going to add those two files and then git status again to see that those files have been added to the index. They're now in green. And then I can go ahead and I can commit using that same commit message, that introduce mod method. If I git status here, we can see we've got that one commit sitting on top of origin main. A git log one line shows me that I've got that commit called introduce mod method. But if I git show head or I git show that SHA-1 hash, we can see that now my commit is actually what I wanted it to be. So it's just the introduce mod method with our two changes, adding the actual method and then adding the test. We don't have all of that Gradle stuff anymore. So that's how we can go back and basically fix the most recent commit to remove stuff that we didn't want included. There we go. That's it. So we just looked at what happens if we've committed something in our most recent commit and we realize that we didn't actually want to have those things in that particular commit. That's a relatively easy state for us to get back out of. But sometimes you committed something in a commit and then you've kept working and it's only later that you realize that that earlier commit contains some sort of mistake, has files in it that you wish that you hadn't tracked. So we're going to get ourselves into that pickle and then we're going to get back out of it. So I'm going to give us a git log one line here. We have this introduce mod method commit. When you weren't looking, I went ahead and I made that commit kind of gross. So I'm going to show you what's inside that commit with that git show and then the SHA-1 hash of the commit. What I did here is that I added all of that Gradle stuff back into this commit. So we've got a bunch of stuff talking about binary files. This is a good sign that there's stuff in this commit that we don't want in here. If I get all the way to the very, 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 very bottom, we can see that we do have the work that I did want. It's that introduce mod method work where we added the method and we added the test. So we've got this commit and we have stuff in it, but let's just pretend we don't know it's there. We missed it somehow and we've moved on to new work. We don't realize that we have problems in this commit. So I'm going to hit Q to escape out of that, Command K to clear my screen, and we're going to go ahead and proceed as though we're good to be doing some additional work. So I'm going to add another method in here. I'm going to add an additional multiply method. And in that additional multiply method, I'm going to take in an extra argument. So we're going to take in this extra argument C, and we're going to return A times B times C. So we've got three arguments now. We're going to multiply all of them together. I'm going to switch over to the calculator test. In IntelliJ, there's actually a command for that. It's Command-Shift-T will open up my test file for me. So Command-Shift-T if you are using IntelliJ. And then I'm going to copy that particular test, this multiply test, and we're going to call this test multiply 3 arguments, and I'm going to add another number in here to multiply a third thing. So we're going to multiply 2 times 3 times 5. I'm pretty sure that that's going to give us the result 30, but of course I want to make sure that my tests pass. So I'm going to give IntelliJ a second to run that test. Beautiful. So my test passed. I'm going to give Gradle a chance to run all of my tests, make sure that everything is in a really good state. Great. So we've got a change. We've run our tests. We are going to run git status here. Oh gosh, I can see that we have a whole bunch of stuff where we're trying to add these Gradle files. So this is going to be that kind of reminder here that something has gone wrong, right? Git thinks that it knows about Gradle files, and I really wish that it didn't. So this is the moment where I've realized I've made some kind of mistake. So what I'm going to do here, I'm going to do a couple of things. The first thing that I want to do is just commit the stuff that I know I want to commit. So I'm going to commit the stuff that's in this app directory. I'm not going to commit this Gradle stuff. So I'm going to git add just the app, and then I'm going to git status, of course, to see where I am. So I've got the calculator and calculator test changes that are ready to be committed, and then I have all of these extra Gradle changes that I actually don't want to commit. I'm going to git commit-m, and we're going to say that we introduced, oh gosh, it helps if I can spell introduce, multiply 3 numbers. I'll say arguments. multiply 3 arguments. I still am not spelling correctly. There it is. Introduce multiply 3 arguments. I'm going to change that. Introduce multiply method with 3 arguments. I like that. That's going to be my commit message. I'm going to enter on that. Get status. And so now I'm in this space where I have these 2 commits and I've got this reminder that something has clearly gone wrong. I'm tracking these Gradle files. I really didn't mean to do that. And so I need to be able to go back in time to that previous commit and make a fix to it. Before I do that, I'm actually going to just clean all of this Gradle output. And so to do that, first of all, I'm just going to call Gradle clean and see if that does it for me. Give that a second to run, and then I'm going to do a get status. Nope, that didn't do it. So in this case, I'm going to actually just remove all of those files because I just don't want them right now. It's all this build output with file hashes. And so I'm going to go ahead and just actually remove recursively everything in that Gradle directory. Oh my gosh, that made everything even worse. Well, now we're like really in a pickle. I don't know what I want to do. Because this says that it's trying to delete everything, and I really don't even want to do that. I just want to like get back to a better state. So I'm going to do get status here. We're really in a pickle. I'm going to get reset hard to head, and I'm going to hope that that actually cleans all of this up. So I've got a bunch of stuff at stage for commit. I really don't want that. I'm going to get reset hard head and make sure that that puts us back into a better state. Oh, perfect. Okay, so we did a get reset hard head. We got rid of all of these changes that were not staged for commit. I just don't want them. I'm in a mess. But at least now we've got it to the point that we don't have these stages or these changes that are not staged for commit. So I'm going to get log one line here. Okay, this is better. I have 2 commits sitting on top of origin main. So we've got the origin main commit. We've got this introduce mod method commit, and then we've got the introduce multiply method. I'm going to get show this last commit, get show head or get show that SHA-1 hash, just to verify. So this commit is perfect. This is just the introduction of that multiply method with 3 arguments. I'm very happy with that. I'm going to get log one line again, and I'm going to look at this one. So get show here, that commit. This is the commit that's got that Gradle stuff in it. So, we've got a real pickle. We've got a commit back in time that has stuff that we wish hadn't happened to us. So I'm going to quit out of this, Q to quit, Command K to clear my screen, get log, get log one line so that I can see where I am. And now we're going to enter an interactive rebase to fix that earlier commit. So get rebase -I, we've done this together before. We know that it's this commit that's causing us the problems. Introduce mod method, it's causing us some problems. I'm going to DW in Vim to delete that word, and we're going to replace that with the edit keyword. So E to edit, a space to separate my command from my SHA-1 hash. I could type the whole word edit instead, I have to type it correctly, or just the letter E. We see that down here in those commands that are available to us. I'm going to hit escape to exit insert mode, and then :WQ to write and quit to get out of Vim. And now Git's going to tell us that we are back in time. We are stopped at this introduce mod method commit, and we can amend it or we can continue. Okay, so I think we're in a good state here. I'm going to get log one line just to see, so we can see that we just have this one method right now. So this one commit. The commit where we added that multiply method with 3 arguments is, we just don't have that right now in this interactive rebase. It's waiting for us, but it's not here yet. So we're in time, we're back in time for this introduce mod method. This is the commit that was causing us some problems. If I get show head now, I can prove that to us. Our head commit is the one that has all of this stuff in Gradle. I'm going to Q to quit out of this, Command K to clear my screen. So we've actually done this step before. We're going to just reset back a commit. We're going to undo some stuff, and we're going to recommit it. So Let's look at that together. Git status again. Woo! I'm in an interactive rebase. Perfect. Okay, so Git's reminding us what I'm doing. I've kind of lost the thread. Thankfully, Git knows where we are. So we're in an interactive rebase and we're editing this introduce mod method. Okay, I'm going to git log one line one more time, and we're going to reset to this moment in time. Get ready for this. So I'm going to git reset, just a soft reset, not a hard reset. I'm going to save my work, but I'm going to undo the actual commit. So git reset back a commit. It's going to tell us that we have these unstaged changes after the reset. So we've got our gitignore and that calculator, those calculator changes. I'm going to git status at this moment in time. Oh, perfect. We've seen this before. So this is basically that same state that we were in previously when we were working on this exact same commit, but when it was the most recent commit. So we've got our untracked files, those Gradle files. We've got the modification to the gitignore. We're still inside this interactive rebase. So we want to be real careful about what we're doing. But we've unstaged the commit. If I do a git log one line now, we can see that our head is currently pointing to the same thing as origin main or origin head. So the actual commit that we're working on, this introduce mod method commit, it's gone. We got rid of it. We've unstaged it. We've reset before that moment in time. Okay, I gotta take a deep breath here so that I can remember what we are trying to do. So we're in this interactive rebase and we wanna commit just the right stuff. We don't wanna commit this Gradle stuff. So I'm actually gonna get that out of the way right now. I'm going to git add only the things that are in that app directory. So git add app, and then I'm gonna git status to make sure that, yes, I have the right changes that are staged for commit. So I've committed the stuff where I added that mod method, and I haven't committed the gitignore and that Gradle directory because we don't want those things. Okay, so I'm gonna actually commit this, git commit -m, introduce mod method. There it is. I'm gonna get status to see it. All right, oh my goodness, we're in definitely a confusing space. So in that interactive rebase, still in progress, here's the last command, which is this edit introduce mod method. We've got these changes that are staged. It says that we are currently splitting a commit while rebasing. So we're in the middle of our previous commit and we've split it into two different things, a new commit and work that's not actually staged. Git status, I just did a git status, git log one line. Okay, we have our introduce mod method commit now. If I git show head, that commit is exactly the right thing. This is only that mod method and only the mod method test. So all of the Gradle stuff is not in this commit anymore. If I do a git status, we've got some changes that are not staged for commit, and we've got untracked files. We're going to go ahead and just obliterate that. So I'm going to use a hard reset to head inside this interactive rebase, and we're going to get rid of those changes. So git reset. Let me just log one line one more time. Okay, this is head, introduce mod method. I'm going to git reset hard to head. I'm going to keep that introduce mod method commit, and I'm going to get rid of my Gradle stuff. So git reset hard head. Okay. Every time I do a git reset hard head, I just want to make so sure that I'm doing the right thing. So this looks good to me. Head is the commit that I want. Everything else, all those Gradle untracked files, I just want them to go away. So git reset hard head. Okay, and then we're going to do a git status again. Oh, beautiful. This is great. So we're still inside an interactive rebase. We have nothing to commit. Our working tree is clean. We have recreated that introduce mod method so that it's actually the thing that we want it to be. It doesn't have the Gradle stuff inside it anymore. We have some options here. We can git rebase continue. We could git commit amend. We're actually done now. We've done what we want. The commit that we have is the commit that we want. So we're going to git rebase continue. And Git's going to say we did it. we're done. I'm going to git log, I'm going to git status so you can see where we are. Git status. So we are back on branch main. We're not inside the interactive rebase anymore. Our branch is ahead of origin main by 2 commits. If I git log one line here, I can see those 2 commits. So we've got our introduce mod method commit, and we've got that introduce multiply method with 3 arguments commit. So we've got all of our work back. If I git show head on this commit, if I git show this SHA1 hash, the introduce mod method, we can see that that commit now is only the mod method. So everything that was related to Gradle that was like, oh gosh, we did the wrong thing, it's all gone. We cleaned it up, all of it's gone. If I git log one line again, we can see that head here is the commit we think that it is. This is where we added that multiply method that has 3 arguments to it in the test for that piece of work. And then just because we always want to make sure that everything is still working correctly, we've done a whole bunch of different work. We want to make sure that our tests still pass. So Gradle test in this case says build was successful. We feel really, really good about that. So that's how we can actually go back in time to a previous commit, amend the commit, modify the commit, fix whatever was wrong with that commit, get rid of the stuff we didn't want in the commit, and then move back forward again in time with the work that we've done on top of that commit. Now, if that gave you hives, or if it made you sweat a little bit, I want you to know that it also makes me sweat a little bit. So that process is definitely a more advanced process than I would expect you to be using just out of the gate. But I think it's really good to see that it's possible. So we can go back in time, we can undo stuff in those earlier commits. I don't want to be in the habit of doing that, but when it happens, when we need to do it, sometimes that's just, we need to go through that process. So if you're in that big pickle, something bad has happened, I would encourage you to come back and rewatch this video, focus on just this one section when you actually need to do it. If you forget everything that we just did here, if that felt really overwhelming, that is okay. You don't need to know how to do that unless you're actually in that particular pickle. So as software engineers, we need to be meticulous about the way that we approach our work. One thing that I see often when I'm working with beginners is that they'll come to me and they'll say, hey, this isn't working. I tried to build this, I tried to run my tests, and it just isn't working. And when someone brings me that kind of question, I'm going to start with 2 questions in return. So my first question is, when did it work last? And my next question is, what's going on with git status? When I ask that question, when did it work last? I want that answer to be 2 minutes ago, okay? I don't want that answer to be yesterday or a week ago. We want to be constantly retesting and rebuilding our work every time that we make a change so that we know the only possible thing that could be causing a problem is the work that we did in the last couple minutes, okay? So what will happen is that people will come to me and they'll say, well, I'm running my tests. I ran Gradle test in this case, and it says that it failed. Okay. Well, I can tell that it failed because of a compilation error. It's telling us that right here. So it says failed to compile the Java. It's giving us some hints about what's wrong. So we have a symbol that we can't find. So my next question here is going to be, well, let's look at that git status. I'm going to command K to clear the screen, and then we'll run git status. Okay, we'll run the full git status with that -u flag because I like to see everything. Oh, goodness. Okay, so we've got this git status, and this git status is a mess, an absolute mess. If this is a place that you are used to working, where you have changes to be committed, changes not staged for commit, and all of these untracked files, if this is how you normally work, we need to get you out of this habit. This is a mess. I call this the Christmas tree. So you do a git status and then all of a sudden the entire screen is full. We've got a bunch of stuff in green. We've got a bunch of stuff in red. This is the Christmas tree. We cannot be here, okay? Because when we're trying to answer that question of like what broke, we have to investigate all of these changes, right? It's too many things for us to look at. It's not a good use of our brain. So we want to clean all of this up, and then we want to stay in that really clean working state all the time. So we can see that we're on branch main. We've got these 2 commits ahead of origin main, and then we have all of these changes. We're going to work together to fix all of these changes and get ourselves back into a functional state where we've got a clean working tree and our code actually builds. So the first thing that I see here is that I have a bunch of these untracked files, right? So I made a change to our gitignore just so that we could get into this state where we've got all of these untracked files. And we're going to fix that right away. That's our first sign that something is wrong, is when we have untracked files. So I'm going to pop over to our gitignore, and I'm actually going to add that .gradle back in so that we can ignore everything in our .gradle directory. And we're going to do a git status -u now. Whew, okay, all right. So we've fixed one of our first problems. We needed to add something to the gitignore. We've added it to the gitignore, and our Christmas tree is already getting a little bit smaller. But if I run Gradle test, it still isn't going to pass. I still have problems. In this case, IntelliJ is actually showing me that I have problems too. So I have this compilation error in Java, and over on the left-hand side here, we can see that we have a bunch of red squiggly lines. So it's not uncommon when I'm working with beginners that they'll bring me code that's full of these red squiggly lines, and they just keep going forward. They just keep moving without actually fixing the red squiggly lines. When we have red squiggly lines, we cannot keep working. That is an immediate stop and fix every single time. So I'm going to open up this calculator file, and I'm going to look at where my red squigglies are coming from, and I'm going to fix those red squigglies. So one of my red squigglies here is coming from this D. So D here is a variable that just doesn't exist. It's not defined. I'm in this method, I've got the variables A, B, and C, but I don't have D. So either I need to define D or I need to get rid of it. I'm going to pretend that this was just an accident. I don't know how this got here, and I'm just going to get rid of it. So IntelliJ gives us that helpful left hook arrow. So if I click on that blue box and then this left hook arrow to roll back that line, I'm going to roll back that line. That was a change that I didn't actually intend to make, and it's causing me compilation errors, and I'm going to get rid of it. We can see that we still have some issues in IntelliJ, but I've made one change, and I'm going to ask Gradle if that change helped in any way. So we're going to run again, and we're going to see, oh, I've got another error. I have a different compilation error. Okay. This compilation error says that it's in my, in the test package. It's in calculator test. If I open up the file tree here, I can see I've got red squiggles in that calculator test. So we're going to take a look at that particular error. So here we can see that I'm actually referencing a method that doesn't exist. It says calculator.something, and then it says cannot resolve method something in calculator. That's because there's no something method. So same thing, I'm going to go ahead, and that was just a mistake. I'm going to undo it, and it's going to show us that it undid the something, and it's going to actually call that multiply method instead. So that was just a mistake. I'm going to get rid of it. All of my red squiggles have to go away. So I've made a change. I'm going to save that file, and I'm going to run Gradle test again just to see if we've gotten anywhere else. Perfect. Okay, so we still have errors, but our new error here has to do with actual test failure. So we're getting closer to understanding like what's actually going wrong. We've got 2 tests that have failed. The test subtract and then the test multiply 3 arguments methods have both failed. I'm going to give us a git status just so that we can see where we are. Okay, so we still have kind of a mess here. We have some stuff that's staged. We have some stuff that's not staged. These things don't feel like they belong together. So looking at these changes to be committed, I've got a modification to this calculator file, and then I've actually got a new file. And then I have a modification to the calculator test down in the changes not staged for commit. Normally I would expect that changes to the actual code and then changes to the test file would go together. And so I think I want to adjust some of what's happening here a little bit. So just looking at this, I think that I want to unstage that calculator file. So I'm going to get the calculator down here into the not staged area with the calculator test. So let's see, git restore staged, because it's a staged file up here in the index. And I'm going to paste that there. And then I'm going to give myself a git status. Okay, all right, I like this a little bit better. I have the calculator and the calculator test together here in that area that's not staged for commit. And then up in my index, I have the introduction of a new file. So I've added some resource files here, and I just added those for myself in part to give us something kind of complex to work with. I've also added another file down here, this additional resource file. And those two things I've decided, those are good. I want to actually put them together and commit them. So I'm going to actually add that file, git add that file, and then I'm going to do a git status. Perfect. So now I have these two resource files together that are ready to be committed. I'm pretty sure that that's a commit on its own. And so I want to actually commit that work. And when I do that, I want to make sure that it actually still builds. So I'm going to commit it, and then I'm going to build it separately. Git commit -m add resource files. Okay, so I've created the commit, git status. All right, so my git status is looking a lot better. We used to be in that really big Christmas tree state, and now I'm actually down to just having 3 changes that are not staged for commit. But I did just commit something, and I didn't actually run my tests. So I am going to, I'm going to do a git stash so that we can run tests against only the stuff that's actually committed. So I'm going to do a git stash here. I don't git stash a lot, but it's a nice tool to have in our toolkit. So I'm going to git stash, and then I'm going to git status. And right now, okay, this looks really good. I'm back in a state where I have 3 commits sitting on top of origin main. I'm on my branch main, and I have nothing to commit. My working tree is clean because I actually stashed those working tree changes. So just to make sure that that commit was a good commit, that it actually works, I'm going to run Gradle test at that moment in time. Beautiful. So that moment builds. So we're in a really good state now. We know that what we've committed builds. We've got some stuff that's stashed. I'm going to bring that stashed stuff back. So git stash pop. There it is. So we have 3 files that are not staged for commit. We have some changes here. And then I'm going to run Gradle test on those files. All right, so again, we see that failure. We know that our failure is coming from those files specifically. So I'm going to look at those files again. Git status. We've got changes to the gitignore, and then we've got changes to this calculator and calculator test. I'm going to look at the changes that I have in this gitignore. Let's see. So let's see. Git diff. Oop, helps if I spell. Git diff.gitignore. Okay, so the only change that I have in my gitignore is the addition of this new line. It says new line in gitignore. Gosh, I did that and it doesn't have any meaning. That's not actually a real thing. Somehow I've changed that file and I don't want it. I don't want the change itself. So I'm going to git status, and I'm going to let git remind me how I can do this. It says that I can git restore the file to discard changes in the working directory. All right, I'm going to do that. So I'm going to git restore the gitignore. And then I'm going to git status to see that I did it. So now we don't have that change. I had changed something in gitignore. I didn't actually want it. I git restored it, so I don't have those changes anymore. So now I only have the calculator and calculator test changes that are here, not staged for commit. I'm going to run Gradle test again. I'm pretty sure that my tests are still going to fail, but let's let Gradle tell us that. Perfect. So we still have our test failures. And we only have these 2 changes, the calculator and calculator test now, that could possibly be responsible for those failures. If I do a git diff, I can see what I actually changed. Oh, okay. Oh, I have some unrelated changes. Here I've added a new method that is going to add 3 different arguments together, so A, B, and C. And then down here, I have some changes that I made to the actual test file. And this one, it says that I added a comment and break the test. So what I did here is I actually changed the assertion from 1 to 2. It says calculator subtract 2 minus 1. That should be 1. And I actually changed something in the test itself. and it broke my test. If I go over to IntelliJ and I try to run these tests, IntelliJ will tell me that these tests don't work. So let's just do that for fun. Give it just a second. It says 2 tests failed. And it's going to show me what those tests actually are. Perfect. It says, I'm going to give me a little bit more space here. So that test subtract, it says expected 2, but was 1. And then my test multiply, it said expected 22, but was 30. Okay, so where are those? There's the test subtract method, and then there's this test multiply 3 arguments method that says that expected 22. So these are 2 changes that I made that actually, like, the tests are just wrong now, right? It's not the right test. I don't actually want this change at all. I'm going to quit out of this. So git status. And we're going to restore this. So I've made changes to these tests that I just really don't want. And that's why my tests are breaking. So I'm going to copy that, and then I'm going to git restore that file, the test file. Git status. Okay, now I'm down to just the changes in the calculator. Git diff to see those changes. It's just adding that actual, the new method that adds 3 different arguments together. I'm going to Command K to clear my screen, and then I'm going to Gradle test to make sure that that actually fixed my tests. So beautiful. Okay, so now our tests are passing, our build is succeeding. When I do a git status, I've only got the 1 change here in my changes not staged for commit. So we started with that giant Christmas tree, the really big mess, and we've iteratively worked through all of it to organize it, clean it up, commit the stuff that we wanted, get back to our tests actually working. The thing I was trying to do was create this new method that adds 3 arguments together. So I'm going to go back to that calculator class, and it was this method here that add 3 different things together. We're going to write a test for it because when we make changes, we always write tests. So we're going to add a new test. I'm going to just copy and paste this here. Git add 3, what did I call it down here? 3 arguments. So I'm going to call it the same thing. Git add 3 arguments. Can't spell. And I'm going to add my 3rd argument here. So we're going to add the numbers 1, 2, and 3. There it is. We're going to add that. And of course, now I'm going to do a git status. I can see that I've made changes to the calculator and the calculator test. So I've got my new method. I've got my new test. I'm going to go ahead and run Gradle test to make sure that all of my tests pass. Oh, one of my tests failed. So now we're in that perfect state because we only have a super small change. We added a new method, we added a new test, we tested it, and the test failed. We know exactly which test failed and why, right? It says right here, test add 3 arguments failed. We can come over here and we can ask IntelliJ to run that test for us so that we can get a little bit more information, maybe some more helpful output. Okay, it says expected 2, but the answer was 6. So I'm looking at this assertion here. It says expected 2, and then I tried to add 1, 2, and 3. Oh, that is exactly the mistake. I'm expecting 2, but 1, 2, and 3, 1 plus 2 plus 3, that's going to be 6. So I'm going to fix my test. I'm going to rerun that test in IntelliJ. Beautiful, my test passes. I'm going to run all of my tests with Gradle over on the right-hand side. All of my tests pass, my code builds. I'm going to do a git status to see I just have the change to the calculator and to the calculator test. Perfect, I'm back down to just my atomic change. 1 change about 1 concept. I'm going to do a git diff just to double check it. We have the addition of this new method. We have the test that goes with it. I'm going to git add both of those files, git status to make sure I did it correctly. We've got changes to be committed. It's those 2 files. I'm going to commit that, git commit-m. And I'm going to do that, let's see, it was introduce add method with 3 arguments. I think that's the name of this commit. Git status. There we go. Okay, so now we are back to where we want to be all the time. Nothing to commit, working tree clean. I've got 4 commits sitting on top of origin main. In general, I prefer to only have maybe 1 or 2, but we haven't pushed things to origin main in a while. I'm going to do a git log 1 line so that we can see we have the commit where we added those resource files. So we were in that big Christmas tree mess where we'd created some new files. We created that commit just for adding those resource files. And then we've got the commit where we added that new method. So we've split out all of our work into the logical, tiniest little subunits of work that we can make. And then we've committed them all separately. We're back into that working tree being totally clean. And now, anytime that we make changes, we're going to know that it's our most recent change is the last thing that we did that broke something, right? So when I say, when did it work last? You can say 2 minutes ago. We're going to pass some commits up to origin, and then we're going to pull them into another space. So let me explain what I have set up here. Over on the right-hand side, I have the window that we've been working in this whole time. This is us. We are on our local main branch. We'll do a git status over here so we can see exactly what's going on. So we have 4 commits ahead of origin main on this side. And if I git log 1 line over here, we can see exactly what those commits are. So we've got our whole commit history. This commit here is the last commit that we have pushed out to origin on origin main. It's also called origin head. And then we have 4 commits locally on our local main branch that are sitting on top of origin head. So this is the view on our side. On the left-hand side over here, I've actually pulled the same git package but into a different directory so that we can work on this as though we are our own teammate. So up here you can see that this one says that we're in my home directory in a directory called collaborator. So on the left hand side here, we're going to pretend that this is somebody else. This is someone else on our team, and we're working with that person, and we want to push some commits so that they can get those commits in origin. So on their side, if we do a git status, we can see that they are up to date with origin main, so they're on their own local branch main. Up to date with origin main. Their local main and our local main are not related to each other at all. They don't talk to each other at all. The only way that we communicate with each other is through origin. I'm going to run a git log 1 line on this side, and we can see that the git log on both sides is slightly different. So over on the right hand side here, we have, again, that commit that we've pushed all the way up to origin, and then our 4 commits sitting on top of it. Over on the left-hand side, all we have is that commit at origin main, origin head. It says introduce divide method. That's that same commit over here with the same SHA-1 hash on both sides, 593 and 593. So this is exactly the same work out in origin. We've got it on both sides. On the right-hand side, on our side, we have 4 extra commits that our friend, our collaborator, does not yet have. So on this right-hand side, we're going to push a commit out to origin, and then we're going to pull that commit on the collaborator side. So again, when I want to push a particular commit to origin, it's going to be git push origin, the SHA-1 hash of the commit and the branch that I'm pushing on. So this SHA-1 hash here is that introduce mod method commit. I'm going to push that. We're going to give GitHub a chance to resolve it. And then we'll do on this side a git log 1 line. And we can see that the reference to origin main or origin head has moved up now. It's now pointing to introduce mod method, whereas before it was pointing to introduce divide method. So we've pushed 1 more commit out to origin. This means that our collaborator will be able to pick up that commit. The first thing we're going to do over here is just to git status. So on this side, it says that we're still on branch main, and it also says that we're up to date with origin main. That's because we haven't actually fetched those changes. So we haven't told Git to go out to origin and get the changes and update our local copy of origin main. So one way that we can do that is to run git fetch. git fetch is going to go out, in this case, to GitHub, and it's going to pick up the changes in origin, but it's not going to apply them to our local main quite yet. So I'm going to run a git status one more time. Beautiful. This says that we're still on branch main, but that we are behind origin main by one commit. So there's a commit out in origin main that we don't currently have on our local main branch. We know what commit it is. It's this one. It's that introduce mod method commit that we pushed on the right-hand side. Over here it says that we can use git pull to update our local branch. So we're going to go ahead and do that. Git pull. Git doesn't love this command. So even though it told us to git pull, it does say here that pulling without specifying how to reconcile is discouraged. What they mean here is that if we want to pull, we should give it some options on how to reconcile. The one that I'm going to use the most often is going to be a -- rebase. Git pull rebase basically means that we're going to take those new commits and we're going to stick them underneath any commits that we have locally. Because we don't have any commits locally, we don't actually have anything to stick these new commits under. But we're going to do a git status here and we'll see exactly what we have. So it says now that we are on branch main and that our branch is up to date with origin main again. I'm going to command K to clear the screen and then a git log one line, and we can see that we now have that introduce mod method commit here. So we've got a new head for our local main. It's the same as origin main and origin head. It's that introduce mod method. We got it from our friend on the right. And so now we're totally up to date. I'm going to do that one more time just so we can see that process again. So I'm going to come over on the right-hand side and we're going to push this commit out to origin. Git push origin, the name of the SHA-1 hash, colon, and then the branch that we are pushing to. It helps if I type it correctly. So I'm going to push this SHA-1 hash out to main. I'm going to give git a chance to reconcile that. We'll do a git status. We now only have 2 commits locally sitting on top of origin main. And if I git log one line on this side, we can see again that that reference to origin main and origin head has moved from the introduce mod method up to this introduce multiply method. So now this commit is out in origin. And our collaborator on the left-hand side can go ahead and pick that up. Last time we did a git fetch. We can also just do a direct git pull -- rebase. That's what I'm going to do almost 99% of the time is a git pull rebase. Before we do that, we're going to do a git status just to see where we are. We're on branch main. It says that we're up to date with origin main. We know that's not true because we know that there's an extra commit over here that we don't have over here yet. So we know that git is just a little bit behind. Git doesn't know about those changes in origin main yet. I'm going to give us a git log one line on this side so we can see where we are. We've got that introduce mod method commit. We're missing this introduce multiply method commit. And so now we're going to go ahead and run git pull -- rebase. And we're just going to directly rebase against origin main with that most up-to-date origin main commit. So git pull rebase. Give it just a second. It's going to tell us that it fast forwarded. It's updated our main to point to origin main again. We can see that we fast forwarded these 2 files. So calculator and calculator test had a couple of changes to them, and that's what we got with that git pull rebase. I'm going to command K to clear my screen and then git log one line. And now we can see that our local main, local head here is up to date with what we have pushed out in origin. We've got that introduce multiply method with 3 arguments over on the left-hand side. So our collaborator now has that commit. That's the last commit that we've pushed on the right-hand side. So that's a quick introduction to git pull rebase and updating to make sure that we have the most recent changes that are in origin. In the next section, we're going to go a little bit more into depth about different ways that we can interact with that git pull rebase. now we're going to put ourselves in a state where we have commits on both sides. So we have our own local commits and our collaborator has commits. We're going to push some of our commits up to origin, and then our collaborator is going to do a git pull rebase to get our commits underneath their own local commits. So the first thing that we want to do always, again, is going to be that git status. We're going to do that on both sides here. So again, on the right-hand side in the dark blue, that's us. And on the left-hand side in the white, that's our coworker. So we have 2 commits right now sitting on top of origin main, and our coworker doesn't have any commits over on origin main. They are on their own local main. They're just up to date with origin main. So we're going to run a git log one line on both sides here, just so that we can see exactly where we are. So on our side in the blue, this is us again, we have these 2 commits, add resource file and introduce add method with 3 arguments. So these are our 2 commits that we haven't yet shared with our coworkers by pushing them out to origin. On our collaborator side, they just have a totally clean working tree with no local commits. So they just have origin main, origin head. That is the head of their local main. And the commit that we have here is introduce multiply method with 3 arguments. So that's the same commit right here, okay? So we're going to pretend that we are the collaborator now. So we are the coworker out there doing our own work, and we're going to make a commit for ourselves. I'm going to imagine that our coworker here wanted to update our README. So let's see. I think if I ls, we've got a README. I'm going to vim the README because we can see there's actually very little in it. And we're going to make our README a little bit more interesting. So this package was intended, we'll put it in the present, is intended to help teach Git. You can use it to practice Git. Okay, all right. So our collaborator is working on the README, getting that README totally up to date. That's not our task, so we're not doing that. So I'm going to escape and then :right quit on the collaborator side here to save the difference in the README, and then we'll do a git status. So we've got that modified README in our working tree, changes not staged for commit. We're going to go ahead and add the README and then git status. We can see that we've got that README in the index, so it's ready to be committed. Git commit -m, and we're going to say update README. Beautiful. Okay, we're going to do a git status here. It'll tell us that we have 1 commit sitting on top of origin main in our local branch main. I'm going to command K to clear the screen there, and then it's going to be a git log --1 line. So again, we can see that we have this commit. Here it is, update README. Okay, it's sitting on top of origin main or origin head with that commit introduce multiply method. So we can see now that on our side, we have 2 commits called add resource files and introduce add method with 3 arguments. And our collaborator has this update README. They haven't pushed their commit out to origin yet, and we haven't pushed our commits, these 2 commits, out to origin yet either. Okay, so now we're going to go back to being ourselves. We're over here on this right-hand side, and we're going to go ahead and actually push this commit out to origin. So we're ready to put that out in a place where the rest of our coworkers can get to it. I'm going to copy that SHA-1 hash, and then it's git push origin, the SHA-1 hash, : the branch that I'm pushing to. Give Git a second, or GitHub a second to handle that push, and then we'll go ahead and do a git status on this side. So before we had 2 commits sitting on top of origin main. Now we only have 1 because we've pushed one of our 2 commits out to origin. I'm going to command K to clear the screen, and then git status one more time, git log 1 line. Perfect. So we can see on this side that origin main, origin head is right here. It's that commit called add resource file that we just pushed to origin. And we've got 1 more commit locally that's sitting on top of it. Over on the collaborator side now, so this is our coworker, this is somebody else, that person needs to pull or rebase from origin main because we've pushed changes. They want to make sure that they have those changes, and we want to be pulling from origin main all the time, anytime that anybody else makes changes to origin main, we want those changes on our side immediately. So our coworker is doing a great job and they realize, hey, there have been some changes. I want those changes right away. So they're going to do this git pull rebase. What's going to happen in the git pull rebase is that our commit that we've just pushed to origin main is going to pop up in between these two commits. So origin main, origin head on their side is going to get updated accordingly. And this update readme commit is still going to be sitting all the way on top of all of that work. So it's just a git pull rebase over here. There we go, we did it. And then a git status, we should still have one commit sitting on top of origin main. There it is, one commit sitting on top of origin main on our local main branch. I'm going to command K to clear this screen, and then we'll do a git log one line over here. And there it is. We used to have origin main or origin head pointing to this commit. We did a git pull rebase so that we could get this add resource file commit from our coworker. And we've got this update readme now sitting on top of that, still locally. So I still have my commit locally. I just have added this commit from origin from the right-hand side of the house. Now we're going to do that whole thing in reverse. Let's take a really big deep breath there. And we're just going to do the whole thing in reverse. So let's imagine that we are our coworker. We're over here on that left-hand side in the white, and our coworker is going to push this updated readme commit. So I'm going to go ahead and just git push. Because I want to push head, I don't actually have to specify anything. I can just directly git push that. So we're going to give GitHub a chance to resolve it, and then we'll do a git status. On this side now it says I'm still on branch main. My branch main is up to date with origin main. Command K to clear my screen, and then we'll do that git log one line. And we can see now that this update readme commit is the head of my local main branch. It's also origin main and origin head. Now we're going to switch back over to our own side. So this is our coworker right here who pushed a commit out to origin. And we don't have that commit yet. But again, if we're going to keep ourselves super organized and avoid merge conflicts, we want to be pulling changes from origin as frequently as they are being made. So we know that our coworker has pushed something to origin main, and we want to pull it right away. So over on our side now, on the right-hand side, I'll command K to clear the screen. We'll do a git status just to see. We still have our one commit sitting on top of origin main. If we git log one line, we can see what that is. So we have, as currently as our own origin main or origin head reference, we have this add resource files commit. We can see that that's actually behind, right? Add resource files over here is actually behind origin main. So we need to get caught up. We have our one commit sitting on top of what's currently origin head. We're going to do a git pull rebase on this side, and we're going to get that update readme commit to squeeze in between these two. So we're going to update our origin main reference with that update readme commit, and then we're going to have our own commit locally sitting on top of that. So same thing over here, it's just a git pull rebase. We'll let GitHub resolve that. Command K to clear the screen. We'll do a git status. It'll tell us that we still have our one commit sitting on top of origin main. Perfect. And then if we do a git log one line, we can see that we have the update readme commit from our coworker. So they pushed out to origin main. We git pull rebased on our side to get that commit and put our own work back on top of that. That's a quick introduction to doing a git pull rebase when we have local work on our local main. So when we run git pull rebase, we need to have a clean working tree. Git actually won't allow us to run a git pull rebase if we don't have a clean working tree. So I'm going to get us into the pickle where we don't have a clean working tree and we need to pull changes, and then we're going to get back out of that particular state. So again, over here on the right-hand side, we're going to imagine that this is us. Over on the left-hand side is our collaborator working on the exact same repo at the same time as us. So the first thing we're going to do is we're going to give our collaborator some work that they are going to push out to origin. So I'm going to do a git status here. We see that we are up to date with origin main. If I do a git log one line, we can see that our last commit that we've pushed to origin main here is this update readme. This is the head of our local main branch. We're going to go ahead and make another change to that readme. So our collaborator, our coworker, is really doing some documentation upgrades today, making some great changes to this readme. So we're going to open that readme in Vim. We're going to hop down to this line. In Vim, it's $sign to get to the very end of the line. And then I'm going to hit I to enter insert mode. And we're going to add another paragraph here. Let's see, what did our coworker want to add? So let's see, this package was used to create a Git tutorial. Okay, so this is what our coworker has added. It's a little update to the README. I'm going to hit escape and then :WQ to exit out of Vim. We'll do a git status here to see that we have that change to the README. It says not staged for commit. And then we're going to go ahead and add that. Git status to see that it's in our index now. And then we'll do a git commit and we'll say update README with paragraph about tutorial. Okay, there we go. And we're going to do a git status here. We can see that we have one commit sitting on top of origin main, and then we're going to do this git log one line. So our coworker over here has created another commit. They haven't pushed that out to origin yet, so we aren't ready to actually pull it because they haven't given it to origin for us to be able to bring it back down on our side. And now we're going to head back over to ourselves. So we're going to imagine that we are doing our own work. And we're not really thinking about our coworker right now. We're just working on something else. So I'm going to switch over to have IntelliJ open. And now we're back in our own state. So this is just us, just on our side. We're going to do this git status. And we can see that we have one commit sitting on top of origin main. We're going to do a git log one line to see what that is. So this is that introduce add method with 3 arguments commit. We worked on that together a while ago. We still haven't pushed that commit out to origin. We're not ready to push that yet, but we have some other work that we're ready to start doing. And so let's go ahead and just start on that. We're going to make some changes that are not real changes I would actually make. We're going to add some comments to these methods. So in general, our method names are self-documenting. We don't actually need to add a comment here, but we're doing this just to have some work to make our working tree dirty. So what we're going to do here, let's see, is method to add 2 integers. Go ahead and give ourselves another one here, method to add 3 integers. Okay, so now we have some work on our own side. I'm going to do a git status to see that change. We can see that we've got a change to this calculator.java file. It's not staged for commit yet, and we know that we have a dirty working tree. If we had a clean working tree, Git would tell us that, and Git's not currently telling us. We can see red file, dirty working tree, okay? Now we're going to head back to that other tab, the tab that our coworker was working on. So our coworker has decided this commit's great. That update README, I'm ready to push it to origin. So our coworker is going to push this. And we're going to do git status here. We can see that we are still on branch main. We're now up to date with origin main. I'm going to command K and then git log -- one line to see it. So we can see that we have pushed, or rather our coworker, this isn't us, our coworker has pushed this update README with paragraph about tutorial out to origin. Okay, we saw that come through, and we know that it's happened, and we want those changes on our side because we always want to be staying up to date with origin mainline all the time. Okay, so we're over here on our own side, and we know we need to git pull rebase. So let's just go ahead and try that. I'm going to run a git pull rebase, and Git's going to tell me, no way, we're not doing this. It says cannot pull with rebase. You have unstaged changes. Please commit or stash them. Perfect. So Git is telling us exactly what to do. I'm going to command K to clean the screen on our side, and we just git status one more time. Hold on. Let me get up to date here. There. We've got our one change. We need to decide what to do. Git told us that we can either stash the change or we can commit the change. A lot of people like to just stash the change when they pull because it feels really easy. So we can just git stash. we have now saved the working directory and index in state on this whip main. So we've got our stash kind of over to the side. If I git status now, it'll tell me that I have a clean working tree. So git stash is one way that we can get to a clean working tree pretty quickly. And once we're in this state, we could do that git pull rebase. Typically then what people do is they'll run a git stash pop to pop their work back on top of the work that they're pulling from origin. So I'm going to actually run git stash pop right now. So we can see that we got our work back. We stashed it and then we popped it back. In general, I try to avoid using git stash. I think that having stuff over in that stash stack can get a little bit messy. It's easy to forget what's over there. It's just a space where we can kind of lose work or just not have the same awareness of that work as we would if we committed it instead. So I actually prefer to create a whip commit on my own side when I need to pull from origin and I'm in the middle of something else. So we're going to do that now. I'm going to command K to clear the screen. I'm going to do a git status again so we can see the change. We're going to add that file and then git status again to see that it's been staged for commit. I'm going to git commit -m, and then like I said before, I really like to just preface my whip commits with the word whip. That's whip for work in progress. And what was I doing in this? I was adding comments to calculator, cannot spell, calculator meth. This is actually how I type when I'm alone too, is just willy-nilly, nothing goes right. Add comments to calculator methods. Okay, so there it is. We're adding this commit. We've marked it as a whip commit, so we know we were in the middle of something. We're not done. I'm going to hit enter on that, git status. So now it's saying that we're ahead of origin min by 2 commits. And what were we trying to do? We were trying to git pull rebase. So we know that our coworker has pushed out this additional commit, update readme, and now we want to get that commit on our side. So we're going to do a git pull rebase to get that commit over on our side. We let GitHub handle that process. I'm going to command K to clear the screen, git status. We can see that we still have our own 2 commits sitting on top of origin main. If I git log one line on this side, we can see that we have successfully pulled that commit from our coworker. So they updated the README, we pulled that commit. It's down here underneath the 2 commits that we have locally, the 1 commit that we were actually pretty done with, and then our 1 whip commit that we made just so that we can kind of be in the in a nice, super clean state when we're doing that git pull rebase. From here, we have a couple different options. We can keep making changes and then amend this commit. We can also reset and get rid of that commit without losing the work. So we'll do both of those things here just for fun. Give me a second to organize my screens a bit. Okay, so we're going to put ourselves into this state. So we're just focused on our own work again. We have this whip commit that we just were not we weren't done with that. So I'm going to go ahead and add some more. We're going to keep commenting these methods. Again, not a real thing I would do, but just good to show us some changes. So let's see, method to subtract one number from another. Okay, so we've got another change here. Again, we can amend the commit that we had, this whip commit that we were in the middle of, git status, git add all of it, git status again to see that we've staged that change for commit, and then we're going to do a git commit -- amend, and this time I'm actually going to use the no edit flag. The no edit flag here is just going to reuse the existing commit message for this commit and not give us the option to change it. I don't want to change that commit message right now. So git commit -- amend, no edit. I'm going to do a git status. We still have the same 2 commits. Git log one line. We can see that we've got our whip commit still. And then if we go ahead and we do a git show on that particular commit, we can see that we have all 3 of our comments. So we used to have just 2 comments in that commit. Now we have all 3 comments. I'm going to command K to clear the screen. We'll git status again. Git log one line. And then I'm going to show you as well that way that we could just reset and not have this commit. So we made this whip commit specifically so that we could do that git pull rebase, but still have our work really tidily, committed here. If we want to just undo the commit and save that work, one more time, that's going to be a git reset, the SHA-1 hash that we want to reset to. We can use that SHA-1 hash or the head ~1, again, 0, 1, etc. So I'm going to use the SHA-1 hash to reset. We can see that we've unstaged the change. Git status here will say that we have one commit sitting on top of origin main, and we can see that those changes, these 3 comments that we've added, are back in this not staged for commit space. If I do a git diff, we can see that those 3 changes are here, not yet staged for commit. So those are a couple different ways that we can handle a git pull rebase when we're in the middle of another thought. We looked at doing that git stash. Certainly you can do that. I really prefer just that kind of tidy, create the commit, and then do our git pull rebase, just so that we have our work always has a name to it, right? It's tidied up inside a commit, and then from there we can do anything we want with it. So remember that commits, they don't have to be long-lived. They can just be for us as we're kind of cleaning and organizing our work. But that's a git pull rebase when you're already in the middle of something else. If you're new to Git, it might surprise you that we have made it through 30 chapters without actually talking about merge conflicts, because you've probably been in a lot of merge conflicts. The reason that I'm putting this so late in the tutorial is that I want us to avoid merge conflicts at almost all costs. It's not a good space for us to be in. Anytime that we hit a merge conflict, it means that we need to redo and rethink the hard work that we've already done. And it's usually a sign that we aren't being good collaborators with someone else. So it could mean that we weren't communicating with our coworkers about which piece of work we were currently working on. Sometimes it even means that we're not being a good collaborator with ourselves, and we've done some silly stuff with local branches or trying to reorder things where all of our work actually interacts with other pieces of our work. So we want to avoid a merge conflict as much as we can, and we can do that by being good communicators with our coworkers and also to be really meticulous and orderly about the work that we're doing locally. But sometimes they're just unavoidable. Sometimes we just wind up in these gross merge conflicts. So we're going to get ourselves into one, and then we're going to get ourselves back out of one. Again, we're working with 2 different people here right now. So over on the right-hand side, this is us. Working locally. And then over on the left-hand side, we're imagining that this is our collaborator. You can see that we've got collaborator up here to remind us. So over on the left-hand side, the white side, is the collaborator, okay? And our collaborator has been doing some work. So I'm going to show you what that looks like. We've got a git status, 1 commit ahead of origin main. We're going to give that a git log 1 line. So we can see that there's this 1 commit, it's head of the local mainline branch, and it says change variable names in calculator. So our coworker has been in our calculator class changing variable names, okay? I'm going to show us what that actually looks like. Git show head to see the actual commit itself. And you can see that in this calculator.java file, almost every single line has been changed. Every variable that was called A is now called first, all the B's are called second, and all the C's are called third. So our coworker just felt like A and B weren't descriptive enough. It was causing them problems. They wanted a little bit more a longer variable name that helped them understand what that variable actually meant. And so they've gone through and they've refactored the code to use these variable names, okay? Now we're going to pretend that they haven't communicated that with us. They haven't pushed that out to origin, or maybe they've pushed it out to origin and we haven't pulled it yet. So we don't have their changes, and we're just continuing our own work, okay? So I'm going to switch back over to our side here. On our side, if we do a git status, we can see that we are up to date with origin main. If we do a git log 1 line, we've got all of these commits here. We don't have any additional commits of our own work locally sitting on top of that. I'm going to command K again on our collaborator side just to do those exact same 2 commands. So we've got the 1 commit and then this one extra commit on their side, right? Everything else here is totally identical, okay? So we're going to be on our own side here, and we're going to start making changes to that calculator class as well. I'm going to switch over to IntelliJ, where I've got that calculator file open. And you can see that in our version of this calculator file, we don't have those variable names. Our coworker has made these changes, but we don't actually have those changes yet. So we're just going to work in this space with these variable names. And let's just say that the thing we wanted to do was to put all of our return statements on separate lines, right? So this add 3 integers method was already on a separate line, and now we want to make all of our methods look the exact same way. So we're going to make those changes together. Just go through here and make these changes so that all of our methods look the same. And this is our change, okay? So now we've done it. We've changed all of our methods so that the return statement is on a new line. I'm going to save that file, and then we'll do a git status over here. We can see that we've modified that calculator class. If we do a git diff, we can see the modifications. So we can see that we've added the return statement on a separate line instead of on that same line. I'm going to hit Q here to quit out of that, Command K to clear my screen. And then of course, because we've made changes to the file, we need to make sure that everything's still built. So I'm going to run a Gradle test to make sure that my commit hasn't built in and it hasn't broken any tests. Everything is still good to go. So beautiful job there. We made our changes. We didn't break any tests. Git status one more time. I'm going to add everything, so that one file, into the index. Git status to see that we've added it into the index. There it is. And then we're going to go ahead and commit that change. Okay, git commit -m. And we're going to say put return statements on new line. Okay. Beautiful. Do a git status one more time here. It's going to tell us that we have one commit now sitting on top of origin main. I'm going to Command K to clear the screen and then git log one line so we can see that one commit. Put return statements on new line. Now, if we remember, our coworker made changes to this exact same code. So when we try to combine our two commits, we're gonna run into a very uncomfortable problem, okay? So I'm gonna say, oh gosh, our coworker hasn't actually merged the changes yet. Let's have that person merge their changes. So here we are over on our collaborator side. So this is our coworker. They've got their variable name changes, and they're going to go ahead and git push that. Maybe they did this through a code review or a pull request, and we just weren't paying attention. We were focused on our own work. We didn't realize that they had pushed that change and that it was going to conflict with the work that we're currently doing. So they've pushed that change, git status, to make sure that we see that we've got on the collaborator side, up to date with origin main, Command K to clear the screen, and then we'll do a git log one line here. So that change variable names in calculator has now been pushed out to origin by our collaborator. I'm gonna switch back to IntelliJ. And now we're back on our own side. So our coworker just told us, hey, I just pushed something out to origin main. I think you want that, okay? So we're gonna pull from origin and we're gonna wind up in a merge conflict. Git pull -- rebase, here it goes. Oh, good golly. There it is. We can see that it was trying to auto merge. We ran into a conflict, could not apply this put return statement on new line commit. We can add or remove the conflicted files, and then we can rebase continue. We can also abort. So sometimes when I'm just like, this is too much. I don't know what I've done. It's just too much. I might just git rebase abort so that I can get my head together first. So if we git rebase abort, Command K to clear the screen, git status, and git log one line, we can see now that we're no longer in the middle of that rebase. Sometimes that feels nice. But we can also see that we've got one commit on origin main and one commit on our own, and they're not the same. It says your branch and origin main have diverged and have 1 and 1 different commits respectively. That's a little bit hard to read, but it means that our local main and origin main each have one commit. They're not the same commit, okay? So when we did that git pull rebase and then we aborted, essentially what we did here is just a git fetch. We've updated our local origin main without actually merging those changes into our local main. So we've got the changes, but we aren't actually sitting on top of them. Let's do that again. So we're gonna git pull rebase, and we know it's going to cause a merge conflict, and that's okay. We're going to get through it together. So git pull rebase, give it just a second. There it is. We've got that conflict. We're going to do this git status, and it's going to tell us what's going on. Okay. So now that we're in the middle of this merge conflict from pulling that code, it tells us that we're actually in the middle of an interactive rebase. Let's see, it says the last command done was to pick this put return statements on new line. No commands are remaining. So we're trying to add our very last commit to this. Once we're done with this, there's not going to be anything else. We are currently rebasing branch main onto that SHA-1 hash. So that SHA-1 hash is the SHA-1 hash that our coworker created. It's right here, 5C6. So we're trying to get our work on top of that work. It says that we can fix the conflicts and then run git rebase continue. We can use git rebase skip to skip the patch or git rebase abort to check out the original branch, okay? Our goal here is to get through this git rebase and then run that git rebase continue, okay? So we're gonna go back to IntelliJ, and now we have all of these little head pointers that are trying to tell us, hey, something has changed. You can tell my IntelliJ is very upset. Anytime that we have these head flags for our merge conflict, IntelliJ is not going to be happy about it, okay? Oh my gosh, it's so many problems. Again, finding ourselves in this state, being in a merge conflict, we want to do anything we can to avoid it because this is just not fun. Trying to figure out what we need to change to redo our own work, to work with our coworkers' work, it's just not a good use of our very precious brain power. But we're going to get through it together this time, and then hopefully we'll just avoid it in the future as much as we possibly can. So anytime that we've got a merge conflict, we're going to start from the very top of the file and work our way down. And the reason that we're going to do it that way is that as we go, we're going to clear out these red squiggles and it's going to be easier and easier to see what's going on. So here we have two pieces. From these arrows to this arrow, we have two different pieces. So, and the equal sign in the middle is the separation of these two pieces. So this is one chunk of a conflict from these arrows to those arrows. This piece here we can see is the head commit that's coming in from our coworker. And then this piece down here is our commit, right? So our coworker added the first and second variable names, and then we put these things onto separate lines. So we actually want to wind up in a mixed end state here. We want our coworkers' changes and we want our own changes. So we're gonna go through and actually change these variable names again. Now, if this seems like a bad use of time, that's because it is. I don't want to have to redo my coworkers' work. I want to communicate with that person about what they're doing and make sure that we're not working on the same thing at the same time. But there we fixed the first merge conflict. We're going to keep working our way down the file. We see that that next merge conflict, these little head flags. So this is the next section where we have a conflict. Okay, so I can see what my coworker did, changed the variable names, and then I can see what I did. I put these things onto separate lines. So again, I'm going to just copy what my coworker did to preserve their changes. Change that from first to second. If you're watching me right now and you're like, Alyssa, there are refactoring tools that would make it easier for you to change your variable names, you are absolutely right. I'm not teaching that right now, and so we're not going to get into it. I made a mistake. You got to be really careful. First times second. Again, having to redo this work and having to be really careful about making sure we wind up in the right end state is why we just don't want to be doing this in the first place. Okay, we have fixed everything all the way down to here. Here's our next one, from the triangles to the triangles. So this is the next thing that needs to get fixed. Same thing. Yeah. If you're like, man, I don't want to watch you do this anymore, well, then don't create merge conflicts, okay? Here we go. I think that worked. Oops. Yeah. All right. A couple more. So I think now we have the right end state. We've got their variable names. We've got my formatting. I'm going to delete that piece, and then I'm going to delete this piece. And now I know that IntelliJ is saying that I have some problems, and I can't tell if those problems are real or if IntelliJ just hasn't quite updated yet. I'm going to go ahead and run Gradle test to see if we got all the way through it. Make sure our tests pass. Okay, it looks like our tests do pass. I'll run them inside IntelliJ too, just to make super double sure, because I do really want these related problems to clear up. Sometimes IntelliJ just takes a second to realize that there aren't actually any problems. So all 7 of our tests passed inside IntelliJ. I'm not actually sure why IntelliJ is giving me those problems. We're going to ignore it. Okay, so we went through, we fixed everything. I'm pretty sure we did it correctly. All of the variable names have the variable name that our coworker created, first and second, or second, third, and then everything has the formatting that we created. So I think that looks really good. I'm going to do a git status now. So again, it still says that both have modified this file. This is the command that I'm looking for. It says use git add file to mark resolution. So I believe that I've completed the resolution of this merge conflict. I'm going to go ahead and let's see, git add, we'll just add the whole app directory. Do a git status. Okay, same thing. I'm going to read this again from the top because Git is telling me everything I need to know. So I'm still in the middle of this interactive rebase. I'm trying to complete the picking of this commit. Once that's done, there's not going to be anything else that comes after it. I'm currently rebasing my local main onto my coworker's this SHA-1 hash commit. It says all conflicts fixed, run, git rebase, continue. Okay, so I think that we've actually done it. I think I'm going to be able now to run git rebase, continue. Git is giving me an option to reword that commit. So it's just the same commit that we've been working on this whole time, but if I wanted to give it a new name, I certainly could. I'm going to escape : right quit to get out of Vim. Whew, okay, I think that we have done it. So I'm going to do, we'll clear the screen here, Command K to clear the screen, git status. We have one commit sitting on top of origin main. If I do a git log one line now, we can see that we have our coworker's commit, that 5C6 commit that says change variable names in calculator. We have their commit. It hasn't changed. The SHA-1 hash is exactly the same as it was on their side. I'll just show that to you again to prove it. 5C6. So we have their exact commit preserved, and we have our own commit sitting on top of that. Git show head. And our own commit starts from that starting point of variable names being first and second. That's the point that our coworker had gotten us to. And then it just does that, putting these things onto the return statement onto a new line, okay? So we have basically kind of redone our own work with the changes that our coworker had made, and now we're sitting pretty again, but that process just isn't great. It's not fun. It's a place where it's really easy for us to make mistakes. It's very mentally taxing, and we just don't want to do it unless it's absolutely necessary. So we want to be really good collaborators and communicate with the people that we're working with to make sure that we're not working on the same set of files at the same time, or be really good collaborators with ourselves and not do work locally that as we want to move it around, reorder it, bring things from branches back onto our local main, those kinds of things, that we're not doing work that's going to create a conflict. When we are in that merge conflict state, we can get back out of it if we're very careful and we look really closely at those changes. But if we can avoid it, we're going to be so much happier. So that's git rebase, where we've got a conflict during the rebase. The last thing we're going to do together is look at git reflog. So sometimes folks get nervous about doing stuff in Git because they're afraid that they are going to do something that they just can't undo. And there are a couple of things you can do that are pretty hard to undo. But Git actually is here to take care of you. So if we make mistakes that we need to go back in time, the thing that we're going to reach for is the git reflog. Git reflog, I'm going to just run it here. It's going to look really overwhelming at first. So don't get overwhelmed. We're just going to look at it together. Okay, there it is, git reflog. Git reflog looks a lot like git log one line, right? We have a SHA-1 hash, we have our head, our main branch, that origin main, all of these different pointers, and then we have what almost look like commit messages, okay? This is all of the history of everything that we have done in Git. This is actually everything that we have done together throughout the last 5 hours of learning Git. So every command that I have run, Git has saved that moment in time for us. And we can go back to any of these moments. We can create a branch from that. We can do a hard reset to that moment. We can enter a detached head for that state. So we've got this reflog, and it is preserved every single moment, even the things that we didn't, we don't have a commit that we could go back to. So I'm going to show us how we can use the reflog to go back to a specific moment in time permanently. So we're gonna do a git reset hard to a previous moment in time in the reflog, so that you can see what that actually looks like. So we just did a fixup lesson where I created a commit, and then we did a fixup, and we fixed up, or we squashed that commit into a previous commit. Let's say that was a mistake, and I just don't want that fixup to have happened. Here in the reflog, we can find the moment where right before that happened. So here's the commit where I actually created the commit that I was going to fix up. And here's where it actually got fixed up. So that's where it actually got pushed into a previous commit. If I just want to go back in time to that moment, I'm going to use this reference here. So this is a way that we refer to moments in time in the reflog. It looks a lot like other markers that we've seen, but it's special. It's his head, and then it's got that @ sign, and then we've got those curly brackets. And we can see that these are counting backwards. So 0 is our most recent moment in time, and then we've got 1, 2, 3, 4. We can use this reference the same way that we've used head or head ~1 or other references. So I'm just going to copy that. I'm going to hit Q to exit out of the reflog, and then Command K to clear my screen since the reflog there is a little overwhelming. And we're going to do a git reset hard to that moment in the reflog. So remember that a hard reset is, we're really going to lose work here. So we're really going to go back in time to that moment before I actually completed the fixup, okay? Anytime that I've got git reset hard on my screen, I'm going to think a little bit for a second before I do it. There we go. Okay. So what we've done here is we've actually moved back to the moment before I completed that fixup. If I do a git status now, we can see that I've got 3 commits. If I do a git log 1 line, you can see that that update test method commit is here. And the fixup commit is currently head. I can git show that commit, and we can see, so there's actually that moment in time we have undone our fixup. If I Command K here, I'm going to open that reflog again, and we're going to see if we can undo the undo. I actually don't know if this is going to work. So git reflog, there we are. Okay, perfect. So we can see here that head at 0 is this reset moving head to head at 4, okay? Let's say I want to actually undo my undo. We've got this reference to head at 1, which was that finishing of this rebase, okay? So I'm going to actually copy that reference, and we're going to try to check out to that moment in time. So Q to exit out, and then Command K to clear the screen. And I'm going to do a git reset hard to this head at 1. There it is. All right, we're going to do a git status here. Oh my gosh, now I only have 2 commits. If I git log 1 line, we can see that we've moved actually back forward again in time. And so what we've done here is we did a fixup, we undid the fixup, we redid the fixup using git reflog. If I git show this commit, git show that's head ~1, we can see that we've got our fixup back. So don't worry too much about reflog. It's fun to play around with just to get a little bit more familiar with it. I think the most important thing to know is that your history is still there. Even if you do something catastrophic, we can almost always recover from that moment. So just know that the reflog exists. If you need it, it can help you. If you get to that point and you are feeling a little bit panicked, come back and re-watch this portion of the reflog, or maybe work with a buddy the first time that you're doing stuff in the reflog. But Git has your history. We don't have to be afraid that we're going to totally lose our work. All right, that's it. That's the end. Obviously, that's not all of Git, but it's the parts that I use on a daily basis in a production environment. I really hope that you found this helpful, and I hope that it serves as your foundation as you develop your own workflows using Git in your production environment. If you've got questions or comments, feel free to leave those comments on the video or send me an email. I love to hear from you. Good feedback, negative feedback, anything that I can use to help improve this for the future, anything that felt confusing. Really does mean a lot to get that feedback, so feel free to send me an email. And with that, I'll leave you to the rest of your day. Good luck in your career as a software engineer. I know that you are going to do great.